Well, it's 10:05. I think we'll go ahead and get started with the main part of the presentation. And as people pop in, we'll go from, we'll go from there. So I guess we'll introduce ourselves. So my name is Leif Peevler. You can call me Coach Peevler, that's fine. I'm coach of 16028 Mecha Knights out of Freedom Prep Academy in Provo. And I'm the person running this workshop today. Also, the event at the end of the summer, so first week of August, will be at FPA, where you'll be able to compete and show off what you've learned. So I'll ask the other key folks here to introduce themselves, camera on or camera off, it's up to them. Kirby, if you wouldn't mind introducing yourself.
Yeah, so I'm Kirby Stout. Those who don't know me, I was the lead scorekeeper at every event this past year, and that is my role throughout FTC. And I'm excited to be here, excited to be helping everyone.
Great. And Laurel, if you wouldn't just mind just introducing yourself. I think everybody knows who you are, but just to be sure.
That's okay. Well, I'm Laurel Dodgen. I'm the program delivery partner for FTC Utah. So I was in charge of the championship this year. And I am just thrilled that this camp came into fruition. I am a believer in big ideas. So anybody that has big, crazy ideas, feel free to share them.
Big crazy person, big crazy ideas.
So that's how we got the camp. So
yeah,
it all works.
It does. And if you guys are not best friends with Laurel already, what are you doing? Seriously, what are you doing? You should be best friends with Laurel. She is so helpful. She's so supportive of the teams around here. She'll help you. She's helped us, and she'll help all of your teams get what they need to be the best that they can be. So make sure that you know Laurel.
Thank you, Leif. I do have to do a shameless plug. If anybody needs information on computer science or engineering at Southern Utah University, that is also me. So feel free to get a hold of me, have your parents, send me an email, give me a call, however you want to do it. I'm here.
Sorry, I just got a little sneeze here. It's allergy season kind of thing. So that's why I started blinking all of a sudden. I'm like, crud. All right. Well, we're going to go ahead and get started with the formal presentation. I'm going to share my screen with all of you. Here we go. So for this presentation, I'm going to go over how chassis. So the name of this camp is TECS, the TECS camp. And I'm ashamed to admit, I don't remember what TECS stands for off the top of my head, Laurel.
It is Technology, Engineering, and Computer Science.
There we go.
Other activities that fall under this acronym. So we just took this one too.
There we go. So in this workshop, we're going to talk about what makes a great chassis. Now, for those of you that have come in a little later, just be aware that we are recording this presentation and we will be posting it on YouTube, on the FTC YouTube channel. So if you want to revisit this later, you certainly can. Now, if you don't want your face to be in the presentation, you can go ahead and turn off your camera. That's fine. I would ask for your participation. We're going to have quite a few discussions about these different things. And I don't want it just to be me talking. I want to make sure that you folks are understanding and that you're getting out of this the most that you can. So without further ado, here we go. I always start off my presentations with a comic, as my students will know. So here we go. It says, well, Hobbs, we might as well give up. I can't figure out how to make a robot. This one doesn't do anything. It's past your bedtime, Calvin. You'll have to leave your toys for tomorrow. Okay, Mom, our robot wasn't working out anyway. Gosh, and we spent all day on it too. I thought for sure our robot would save us from making the bed. And in a way, he did. Oh, shoot, I was moving the thing around. Hey, yeah, we're geniuses. So they spent all day building a robot to get out of making their bed, and they ended up not making their bed. So sometimes robotics can feel like this, where you're like, oh man, I've been spending all the day on this robot to help me do something, and then time flies. I'm sure all of you that have done this for any length of time can relate to this whole thing. Okay, so first thing we're going to announce this morning are the alliances. So the camp leadership has placed all of the teams that have signed up into 2 alliances. Now we have some late breaking people that are joining in. So if your team is not on here, email myself and Laurel at the end of this so we can make sure to get you onto an alliance. And we'll be able to figure out this. So we have 2 alliances. We'll have our Red Alliance, which consists of the Masters, Mecha Knights, and then even though it says Checkers, that Checkers includes Checkers, Mandalorian, and the Boys. So all 3 of those teams will be going together on the Red Alliance. Blue Alliance will be Black Ops, the Cubed Ets. I said it right this time, yay. And then Perfect Paradox. I understand we only have 1 member of Perfect Paradox joining in who will, at least for the time being, be working together with Black Ops. Is there anyone here that is not on one of these teams? Go ahead and either unmute yourself, or if you feel more comfortable with just writing it in the chat, go ahead and write it in the chat. Okay. So, you're going to be working together with your alliances for the rest of this camp. Now, I just put Red Alliance, Blue Alliance. If you folks want to come up with a better names for these alliances, I encourage you to do so. Okay. This is just to give you an initial starting place for your alliances. We need 1 adult coach to be responsible for helping out each alliance. I know there's a few coaches here this morning. Are there any coaches that would be willing to volunteer to help out each of these alliances?
And take on the Red Alliance.
Thank you. That's Corinne from the Masters. Excellent. Blue Alliance?
Vic in chat said he can take blue.
Ah, the chat didn't. Oh, yeah, there it is. Okay. Excellent. Thank you. So that's Vic from Black Ops. Great. So each one of the alliances has an adult coach that can help. Perfect. Thank you both. And I'll be happy to support either alliance as we move on. Great. So the next thing we're going to get to is we've set up a Discord server for you so that alliances, because I know a lot of alliances aren't right next to each other. So we've set up a Discord server so alliances can meet and discuss with each other over the course of the summer and help kind of coordinate things. So I'm going to turn over a little time to Kirby to explain how the Discord server works. Do you want me to stop sharing, Kirby? Or...
Yeah, and
Or
I'll
I can
go and
pull up-
switch over to myself.
Okay, yeah, I'll just stop sharing then.
Okay, so we are using the FTC Utah Discord server. We've got a set of voice channels that we can't see here because I'm viewing as a different role. But we've got a set of voice and text channels that we'll be using to communicate for this camp. Once you guys have joined the server, which is on screen here, and I'm going to go and put that in chat as well. That is the link for the Discord server. Once you join that and accept the rules, then you will be able to see almost everything. In order to get you guys assigned in the robotics camp group, we have a form that you guys will need to fill out just so I know what team you're on and match it up with your Discord username. Because we do have separate channels for each alliance as well as a general channel. That link will be coming into the chat here in a second as well.
Yep, there it is.
That form basically just asks for your name, your team, what your Discord username is, and what role you are, whether you're a student or a coach.
Oh, I have a question.
Yeah.
So in the form, should we include our last name as well, or just our first name?
That's up to you.
Oh, okay.
Are most of you familiar with Discord? How it works, all those kind of things?
No.
No. Okay. Kirby, would you mind just kind of giving a quick little rundown for those that have never used Discord, why we're using it and
Yeah,
what it's
so
good for?
Discord started out as essentially a social networking type site for gaming. It has since evolved into a major communication platform, and it's extremely versatile. You have text chat, you have voice chat, you have announcement channels. You can do direct messaging. You can basically do anything, and it's all logged, all real time. We can put various links to different things. We can all collaborate just as we're doing here, but unlike here where it's a set meeting, we can do it any time in Discord. And it also helps keep us safe in first's eyes because everything is logged. And so there's no worries about youth protection. And so we have these channels down here labeled with RC. Those are what we will be using for this camp to communicate with each other.
And a lot of the people that are on here today have used, I know all my team has, we use Discord all the time. So if you're not quite sure how to use Discord, I'm sure there is someone on your alliance that has used it before and can help. And of course, we as the, what are we calling ourselves? Counselors, because this is a camp or something. We can certainly help. Oh, look, we've got some people that have joined the Discord. Yay.
Yes, we do. I went in and stopped sharing.
Okay. All right. Does anyone have any questions about the Discord before we move on? You can either say them out loud or just type them in the chat. Okay. I don't see or hear anything, so I think we'll move on. I'll go ahead and move back to sharing my screen. So for whatever reason, it doesn't pop up as easy. I know where it pops up here, but it doesn't automatically pop up. So Kirby, would you mind watching the chat through this whole thing and just interjecting if someone asks a question in the chat?
Yeah, absolutely. It seems like whenever you go to screen share, it like goes away.
Yeah.
That's why I had so much trouble.
Well, we'll deal with that. Okay. So this is the first of the 4 workshops that will go over what we've lovingly called the chassis block. So before we get into the actual workshops, let's get into the 3 events of our little decathlon. that will cover, that'll give emphasis to the things we're going to talk about today. So first of all, I guess before I talk about the events, the decathlon is something that we've talked about at length between myself and the other people that have worked very hard to put together this event. And we've chosen these 10 events because we think they're the things that are most applicable to help you prepare for the next FTC season. So the first event is simple as can be. It's we're calling it 100 decimeter dash. So decim meaning a tenth, so that's actually just 10 meters or about 32.8 feet. So this event is all about speed. The robot needs to travel 10 meters in as little of a time as possible, go from point A to point B. And this is to help kind of get you folks to think about linear velocity when moving your robot. So all we're going to have is we're just going to have 10 meters of those foam tiles that you're used to driving on. So we will be using the official FTC foam tiles for this. And we'll just have a line, and the robot just needs to get across that line as quickly as possible. However, we would encourage teams to have a way to brake after it's gone the 10 meters. So you're not running into a wall or anything like that after you've gone as quickly as possible. So do you folks have any questions about the first event? Okay, pretty straightforward. Event 2, we're calling this the hurdles. Although this is more of an obstacle course, but I couldn't think of an Olympic event that went along with this, so we just settled on hurdles here. So this event is all about maneuverability. So your robot is going to need to make very tight 90-degree turns, move through obstacles, and finish essentially an obstacle course as quickly as possible. So while speed is a factor, because you do want to finish as quickly as possible, maneuverability is a big deal with this. Okay, I got a Discord ping. We got to make sure. Okay, one of my other teammates is taking care of it. Thank you, Vikram. Just wanted to make sure that okay. So sorry about that. Okay, but yeah, it's essentially maneuverability. We will be giving more details about the course and what kind of things your robot is going to need to do in the 4th workshop, in the last workshop that we're going to be doing. That's where we're going to be focusing on the event and helping you folks getting ready for the event. Do you folks have any questions about event 2? Okay, event 3 then. Event 3 is a robot climb. In this one, robots will need to climb increasingly steep ramps without grabbing onto anything. So grabbing onto the ramp and pulling yourself up is prohibited. In this is all about climbing up with just the torque in your wheels. Okay. So we're going to go as steep as teams want to take it. Starting at about a 20-degree angle and moving up to as intense as people want to take it. So the idea is you'll climb up the ramp without tipping over. The robot that can climb the steepest ramp will win. With time, the time it takes to climb up that ramp being used as a tiebreaker if necessary. And that's about it for event 3. Any questions about any of these these chassis block events? Awesome. So ideally, what we want from your alliances is as an alliance, each team in the alliance is going to pick one of the 3 events to do. So, for example, with Red Alliance, which I'm going to put this up, one team is going to build a robot that will do the 10 decimeter dash. One robot will do the maneuverability, the hurdles, and one robot will do the robot climb. So over the course of this these series of summer camps, and one of the reasons why we're giving you access to this Discord is so you can discuss with the other members of your alliance about which teams are going to do what, and helping and supporting each other to make the best robot you can to fulfill these events. Okay, I think we're all good there. Well, we'll move right along. I'm going to go ahead and just get back out and get to true full screen here. There we go. So, a lot of the resources I'm about to present to you today came from both my experience. I have been a coach for FTC for 3 years, and I've used a lot of the systems that we're going to be talking about today. I'm also inviting a lot of you to share your experiences with these different systems. I don't want this to be necessarily just me talking here, but a lot of the information from this presentation can be found in a resource called Game Manual 0. I'm actually going to type this in the chat so that you can refer to this later on. But gm0.org. This is if you do not know about this resource already, this is an excellent, excellent resource for you to use, particularly if you're getting
there real quick.
Mm-hmm.
That link is also on the Discord in 2 places, actually. That link is both in the resources channel as well as the RC resources.
Excellent. So if you're confused about where to get started, or what a gear ratio is, or what motors you should use, Game Manual 0 is an excellent place. This was written by people that have done FTC, and not just done FTC, but done FTC at the highest levels. Yeah, go ahead, Laurel.
Sorry, Matt keeps talking, so I keep turning off the mic to get more information. I've got Matt. He's one of the judge advisors for the state. We're also married. That's why he's here. But he said that participating and helping other teams during this camp is a great tiebreaker when it comes to judging next season. The judges will be able to see that you've been working with teams throughout the year. So the more you participate and can document that, the better it is for your team.
Yep.
Yeah. And it would be a Motivate Award area.
It looks like we have somebody else that just joined.
Let's see. Rebecca, welcome. Just FYI, this is being recorded. So if you don't want your face to show up in the recording, you can just keep your camera off. But feel free to talk, of course. Or if you don't mind your face ending up in the recording, you can go ahead and turn on your camera too. Up to you.
Thank you.
Thank you for being here. All right, so let's start getting into the meat and potatoes here of our discussion here. So I've split up this into a few different categories about things that you need to be aware of in FTC. Now, I'm going to be showing pictures of these things here, but thanks again to Laurel, I'm going to show you this. I have here a Rev FTC starter kit V3 with a lot of these parts here. Plus, I've got some chassis that I'm going to be demonstrating in person to you folks. Okay, so let's talk about wheels. There are three basic types of wheels in FTC. Now, I do understand that there are a bunch of different subtypes of these things. Not all traction wheels are the same, but to keep things a bit simple today, we're just going to go with the three major overarching categories here. The first one is your simple traction wheel. They're pretty simple. And as the name suggests, they provide the greatest amount of traction. Robots with these kind of wheels are generally harder to push around than some of the others, and they also often have less problems with things like slippage or those kind of things. So pretty much all of the basic kits come with some traction wheels. With Rev, for example, there's a few different types. There's those thinner wheels, and then let me grab the chassis I've been working on here. So here's some of the Rev chassis traction wheels here that come with the V3 kit. Okay. So pretty simple, pretty straightforward. The second type of wheel you need to be aware of in FTC are the Omni wheels. These wheels have rollers in them that sacrifice some traction, so they're definitely not going to get the same kind of traction as our traction wheels, but they can kind of slide side to side like these guys do without having to fully on turn. So Omni wheels are great if you want your robot to be able to turn more easily. The traction wheels don't turn very easily, particularly if you have a tank drive. And depending on how you configure your chassis, they can lead to some very maneuverable types of setups here. And then finally, the third specialty type of wheel that we have are the Mecanum wheels. The ones shown here are the Go Build a V1s, which have been discontinued. A lot of teams still have the V1s. My teams have the V1s. They've Go Builda has released a thinner version, the V3s, I think is what they're on. V3s or V4s, I can't remember. But regardless, the distinguishing factor of these wheels is the fact that they have these 45-degree rollers. And these allow the robot to move and strafe in 8 directions without having to turn. So they are excellent at maneuvering around the field, but that comes at a cost. Mecanum wheels lose a lot of traction because of this. So a robot with Mecanum wheels is much easier to get pushed than one with, say, traction wheels. Okay. They also tend to slip. Now, if any of you have done any autonomous programming with Mecanum wheels, you know that you can't fully count on your encoder counts when you use Mecanum because they can slip and it can throw everything off there. So a lot of Utah FTC, I kind of wish I would have done a formal count when we were at state, but I would say that the majority of teams, now correct me if I'm wrong, Kirby or anybody else, but I would say that the majority of teams in Utah use Mecanum.
I would agree with that. I've seen a few that don't, but most of them are.
Yep. And the thing is, these are excellent, excellent wheels, but one of the things I want to emphasize today is these aren't your only option. And in some games, for example, if you're doing event 3, the robot climb, Mecanum wheels are not what you want to use for the robot climb, because you're going to lose a lot of traction and you're not going to be able to climb as high of an incline as you would if you just use traction wheels. So even though mechanic wheels are excellent, they aren't good at everything. So I want to pause for a moment and give you folks an opportunity, either out loud or in the chat. What kind of wheels have your teams used, either last year or in previous years? So what kind of wheels have you folks used, and what kind of wheels are you familiar with? So go ahead, so take some time in the chat or just unmute yourself. What kind of wheels are you familiar with? And what kind of wheels would you like to learn more about?
Vikram says we've used Mecanum wheels this year.
Okay.
But would personally like to learn more about a traction wheel setup.
Cool.
The Black Ops also use Mecanum wheels. We've tried the omnidirectionals, but last year we used the Mecanum.
Awesome.
Cadets have Mecanum.
Okay.
I would like to learn more about how the size of wheel affects the challenges.
Yes. That's important when we get to using the right gear ratio on those wheels. The size of the wheel does matter on that. Not to mention, getting over obstacles and things like that. So we will talk about that today. So that's a great thing.
Thomas says we used Mecanum wheels this year and last year.
Yep.
Sorry. Masters use Mecanum wheels too.
Cool.
And we had the latest Go Build That One, and they were fantastic. They do not slip as much as the old ones that we had before.
The V4s you're talking about?
Yes, I don't know what version they are. Like the latest, the one they're selling right now.
Okay.
Because we were like, it worked great just with encoders for the autonomous. So
that's good to know. My teams have used the V1s and we've noticed some slippage. So maybe it would be good to use the V4s. Now, out of curiosity, my team, you don't need to answer because I already know. Because my team, Mechanites have used the V1s. So Masters have used the V4s. Has any other teams used any other brand of Mecanum wheels, whether that be Rev or Tetrix or any other?
Our first year we used, I don't know what brand, but it wasn't any of the main ones. But one of our people running the team got them for us. And I don't know what brand they were, other than none of them matched the colors or anything, as far as I can tell, of any of the major brands for robotics. I'm not sure where they got them from, but so it was a different brand, but they worked.
Okay. Great. Go buildas are very popular in FTC for a lot of things. And we'll get to the different build systems a bit later. But one thing I want to emphasize with all this is you don't have to use a particular brand or a particular type to be successful. There are a lot of different ways to succeed in FTC. All right, anything else in chat?
Nothing else in chat. Nick, welcome.
Thanks. Yeah, sorry. Running late this morning.
Nick. So Nick is is one of our head refs for the state of Utah, and he played a huge role in planning out the events and things that we've talked about already today. So he's another person that deserves a huge round of applause, at least from me.
Well, thank you.
So
I
he'll
got
also be
Time zones messed up, so I was thinking we were starting in 15 minutes. So that's my bad.
Oh, whoops. That's okay. We're glad to have you. Okay. All right, I think we'll move on from wheels. Now let's get to the different configurations. One of the big reasons why we're doing this is to kind of introduce you folks to different ways you can set up a chassis depending upon what the game is that year. Now, some teams just use the same chassis year in, year out. And there's nothing wrong with that per se, but there are some configurations that may be better at certain games than others. So as we go along, if you wouldn't mind, if you've used this chassis configuration before in competition, any of the configurations that we've talked about, if you wouldn't mind saying so in chat or just speaking up on the microphone here. So here we go. So 3 questions that I think every team should consider when choosing what chassis to use that year. Question 1 is, what is the right amount of speed, torque, which we'll talk about torque more a bit later, which torque is force in a circle. It has a lot to do with how powerful your robot's going to be able to be, how quickly it's going to be able to accelerate, and if you need to push things, how much it's going to be able to push things, okay? Or resist being pushed is another way to think about it. What's the right balance of speed, torque, and maneuverability for that specific game? And you could even get more specific for your strategy in that year's game. How many of you folks were around for Skystone 2 years ago? My team was...
Cuvettes were.
Okay, cuvettes were... Oops, sorry. So a lot of teams were, that's great. In Skystone, if your strategy is you're going and getting blocks from the corner, what kind of things do you think would have been important choosing your chassis? So let's say you're, for those of you that didn't do Skystone, one of the tasks was you had to go to all the way to the opposite corner of the field, pick up a stone and deliver it, okay, back to your building site. So you had to go a decently long distance, mostly in straight lines. Although if you have other robots that are doing the same thing, you might need to be able to get around them. So what kind of things would you consider if you were to do Skystone again? What kind of things would you consider when you're choosing your chassis? So you can either write this in chat or you can just talk out loud.
It says speed.
Speed would be big in Skystone, wouldn't it?
Vikram, as the bot needed to be fast and didn't need to be as maneuverable, a fast robot was preferred.
Okay. Great point, Vikram. Okay, so now last year's game, Ultimate Goal, how would that be different? How would you approach, if you were to do Ultimate Goal again, what kind of thing do you think would be different in how you would design your chassis? which ultimate goal for, I think everybody hears. I don't think we have any rookie teams here with us today, although we would have loved to have had some. What kind of things do you think would have been different?
From kind of maneuverability was more important.
Yes. Being able to chase down those rings, and along with lining up the shot, right? To hit either high goal or power shots or all those kind of things. Sure. Any other thoughts? Anyway, the point of this is when you're designing your chassis, you need to make sure that your chassis fits what you're doing. Second question, what resources do you have available? Okay. Does your team have infinite money? If so, I'd like some. But but yeah, are you Scrooge McDuck with a big money, the money bin? I know I'm not. My team doesn't have infinite resources. And so we can't afford to buy a new kit every year. And most teams, I dare say, are in that boat where we have to work with what materials we already have. Now, we can save up and fundraise maybe for some additional things, but we have the problem of limited resources. And that's something that we need to consider when we choose our chassis. We can't choose the brand shiny new chassis every year because most teams can't afford that. And then third and finally, how many motors are you willing to use on your chassis? I will tell you from experience, 2 motors on a chassis is usually too few. It doesn't give you enough power, doesn't give you enough speed, and it doesn't give you the maneuverability options that you would have otherwise. 4 is a good number for a lot of these different chassis configurations, although there is at least one configuration that uses 5. In fact, there's one that uses 8, but we're not going to recommend that one for FTC, generally speaking. So, but we'll get there later. But these are some questions to consider when you're sitting down and choosing what kind of chassis configuration you want. And remember, in FTC, you only get 8 motors. So you need to make sure that you leave enough motors for the other things your robot needs to be able to do. Maybe a motor for an intake, a motor for a, for ultimate goal, you would have needed a motor for a shooting mechanism, or maybe even 2 motors for a shooting mechanism. You have to find that right balance, and you have to ask those questions early, because changing up your chassis a month before competition is a very bad idea in most cases. So you want to kind of settle these kind of questions as early as possible. Questions so far? All right. So a quick note, and I took this from a different year. You can see all of these different configurations of chassis here, all these different types of robots. There is no one right way to build a chassis in FTC. And that's one of the things I think that makes FTC so wonderful, is it gives a lot of opportunity to experiment, to try different things. And multiple types of chassis configurations can be effective depending on what's your overall strategy, what do you want to accomplish, and making sure that your chassis fits your particular strategy. So not all teams, and the thing is, I kind of get this feeling with Utah and with a lot of other places in FTC, is a lot of people have gotten mechanism wheels because they feel like they have to have it, because everybody else, all the top teams have it. We feel like everybody needs to have it in order to keep up. Well, Perspective, one of the Park City teams, did you notice that they didn't use mechanism this year? Because they didn't. So don't think that you have to lock yourself in to one type of chassis just because everybody else does it. That's one thing I want to emphasize today. Okay, so let's start with the basic. The very most basic type of chassis you can get in FTC is a two-wheel tank drive. Okay, this is the, a lot of you probably recognize this design. This is the recommended Tetrix pushbot, which essentially it comes, you know, I think the instructions for this are even posted on the FTC website. This is just a very simple bot to get a team start practicing how to build a basic bot. So the description is it just uses 2 motors to power 2 traction wheels. And then you have these 2 unpowered Omni wheels that allow the robot to turn more easily. If you were to put 4 traction wheels on this thing would have a devil of a time getting turned. The only nice thing about this design is it's simple, easy to build, easy to program. This is a great beginner bot, and that's about it. Okay. Because it only has the 2 wheels, it doesn't excel in speed, torque, maneuverability. This bot can be easily pushed around by other bots. This is a good way to learn how to build the basics, but other than that, you really should move past this as quickly as possible, because a 2-wheel tank drive is not very likely to be very competitive in FTC. Just out of curiosity, how many teams have built a 2-wheel tank drive, either in the FTC, the Tetrix configuration, or in Rev? And used it before. I will tell you, when I was at the first school I worked for, which was Capstone, we built one of these. And yeah, it was a great, easy way. Our team didn't have a lot of resources to begin with. So it's kind of what we had to do for year 1. And, you know, it can be made to play the game that you need to, but it's probably not going to win very many awards.
Vikram says their team has built and used one before.
Yep. Yeah, we have. So of all the configurations we're going over today, this is one of those that I would say steer clear of. There are much better ways to build a bot for your buck. 4-wheel drive. Okay. I tried to find a picture. Unfortunately, I found one with 4 traction wheels, which is actually not the best way to do this configuration. It's either better to do 2 traction, 2 Omnis, or 4 Omni wheels. So this is essentially the big difference between the 2-wheel and the 4-wheel is that you're powering all 4 wheels. Now, there are some teams that will kind of do it halfway, where they will use only 2 motors and chain the 2 wheels together, which you can do it that way if you want. Or what I would recommend, 2 motors, again, is not enough, I think, for a chassis. I think it's better to use 4 in almost every circumstance, just for that extra power, extra speed, all those kind of things. So uses a motor on each corner. This is more maneuverable and often more powerful than the 2-wheel drive. And if you want something that can drive over obstacles, so let's say you were doing Rover Rugkiss. I don't know how many teams were around for Rover Rugkiss, but Rover Rugkiss had that giant, that big crater thing. Now, most teams decided not to deal with that and just reached out. They solved the problem by reaching over it. But if you were to drive over the crater and pick up minerals that way, one possible solution to that problem would be just to use larger diameter wheels and just be able to drive over it. Okay. So I think the meta kind of went the reaching over, but still it's a possible solution for this kind of thing. So it's more powerful, more maneuverable. If you've built a 2-wheel drive, doing a 4-wheel drive is a simple upgrade. And I'd highly recommend that you look into this, if nothing else. Problem is, if you have the high wheels that I talked about, the higher you put the wheels, the higher you put the chassis, the higher you put your center of gravity, as we'll talk about later on, the more prone it is to tipping over. So that's something that you have to take into account. Also, 4-wheel tank drives, you have to take into account how you put your weight distribution. This chassis, along with a 2-wheel drive, if you have too much weight on your back wheels, this thing tends to tip back if you're not careful, if you're accelerating very quickly. So you need to make sure, and it's kind of good practice anyway, to have your weight more centered, but it's something that you got to think about. It's not insurmountable. It's not a thing that can, that I say, well, don't use this. It's just something that you've got to consider when designing your chassis. So have any teams used a 4-wheel tank drive, or any coaches? Just out of curiosity.
Macy has.
Macy, do you want to talk about your experience with it?
So it's probably one of the easiest drivetrains to build, and I would definitely recommend experimenting with building it, because it gives you the fundamentals for being able to do more complex drivetrains. Yeah. So when you get to a point where you are doing, through a gearbox or something like that, direct drive to your 4 motors, it allows you to understand how you can independently control each motor to achieve different maneuverabilities, which, understanding how that works is paramount for being able to do mechanism wheels or any kind of omnidirectional movement, right? But on top of that there's a lot of advantages to doing a 4-wheel drive with this. It gives you lots of torque, lots of power. And so it allows you to be able to make a solid and movable object, because your wheels aren't going to let you move side to side. So if you're in a situation where you are playing with other aggressive robots or whatever else, your robot isn't going to move unless they are overpowering your motors, right? Because you're not going to get pushed side to side, so you have forward and backward movement, and that's it. So the limiting thing, though, is that you have forward and backward. But because every single wheel is directly tied into a motor, you also have very strong control and precision of where that robot is going to go. If you leverage something like encoders, or just know how far with your gear ratios your robot can travel and, power burst, you can leverage some automation that it's like, all right, I know if I line up on this thing, I need to go forward, square and a half or 18 inches or whatever else. You could program a button to get you there so that you can very easily start making automations with buttons to help improve your gameplay. I also find that as long as you're not elevating your drivetrain mounting, right, so your wheels are still really close to the ground, you have 4 really solid points that, as long as you keep your center of gravity and your center of mass in the middle of the robot, it's a very solid thing. But it is also easy to build a big old cantilevered object off the back end or something like that, and then you run into an object and your front end kicks up a little bit, and there goes the robot. So there's always give and takes with everything, right? So with this, you're going to get very strong base that's immovable unless you want it to move, depending upon your gear ratios. This also is a way to get you the most amount of speed. If you wanted to do very high gear ratio, you have 4 motors that are going really fast. So this gives you a lot of options still, and allows you to kind of think about, when I'm designing my chassis, what am I going to put on top of it? How are we going to do that? Are we going to have the build space for it? To me, you can make a 4 wheel thing, put your wheels out as your 18-inch cube. I would do 17.5 to be safe, right? And so you have your build spaces, everything within your wheels, and that gives you a really solid platform for being able to visualize, okay, this is what I have to build in. I have to fit everything inside of this, and helps just kind of get you going in a thought process along with that.
Yep. Well, thank you.
Mara says the Cudettes have done a 4-wheel drive, but not a 4-wheel tank drive.
Okay, fair enough. And you know what? A 4-wheel drive, I think, would have been a pretty good option for Ultimate Goal. I think for this year's game, this could have been. I'm trying to think if any teams I saw ever used a 4-wheel drive. I don't think I ever saw one, but this wouldn't have been a bad option for this year's game.
I think there was at least one team that did it via chain. So they all, it was not 4 independent motors, but they had 2 motors all in the same chain gang for the wheels. So it was a more dedicated tank drive, right? Because the difference between tank drive and just 4-wheel drive is that tank drive is you only have control of one side and the other side, forward and back, right? So tank drive is each side has forward and back, and that's your only control. And so with this kind of a design that's like in the picture on the screen, you can accomplish that with software, right? So your software wise, you only, your right stick does your right side, your left stick does your left side. And that can give it, if your driver practices with that, you can get a very large amount of control and precision with that. You can also program a button like on the joysticks we had the D-pad, right? When I was a team, we actually programmed our D-pad so that I could hit left or right and it would do a 90-degree or 100-degree turn. And so I could snap turns really quickly and then just go forward. So there's a lot of things you can do with the software to leverage 4 tank drives to excel and outperform. Because one of the things you have to keep in mind is that you have 2 minutes. So every second that you can automize and every second that you can make more precise and get you further is going to benefit you as a team. Because every second wasted is a second that you're not able to do something that is advantageous for you.
Great. I hope one of the things that you're getting from all this, that we've spent a lot of time on the second most simple drive that out there and how effective it can really be. You don't have to spend hundreds of dollars on the latest and greatest to have a very effective and very competitive robot. Okay, so 6-wheel. As it turns out, this is what I've been working on over the past bit. This is one of the recommended configurations for the Rev starter kit V3. This is a 6-wheel drive. Okay, and as the name says, it uses 6 wheels, okay? Usually a combination of traction Omni wheels. So this is the Rev recommended configuration, which has 4 traction wheels and 2 Omnis. There's another configuration where you replace these two traction wheels on the other side with Omnis, and you only have traction wheels in the center. We'll get to the drop center one in the moment, just in case anybody is itching to talk about that. We're going to talk about that later as a separate kind of, because really it kind of is. In this configuration, you can either use 2 motors. In this case, this chassis is powered by 2 motors, and essentially it's chain. The other wheels are attached by chain. Or you can use 4 motors if you want. To get that extra torque and speed. So this is, I'll tell you, after I've put this together, I really like this configuration, even for beginners. Rev has an excellent guide on how to put together one of these with the FTC V3 starter kit. And it took me about, and this is me working by myself, it took me about 6 hours to put together this chassis. There are a couple of things that were a bit technical in putting this together. I had to learn how to use a chain tool. And that can be tricky for some folks, and it takes a little bit of practice, but it's a worthwhile skill. I think learning how to use a chain skill, a chain tool to adjust different lengths of chain, I think that's a thing that can help not only in building a chassis, but building other things too. So I will say that even for beginner teams or rookie teams, I would almost if I were to start a rookie team, I would rather have them build this than the Tetrix pushbot, to be quite honest, because this is going to serve them better than the Tetrix pushbot. So, and it'll teach them more skills that I think will serve them better later. Oh, it went forward. I was trying to click on the chat. Sorry about that. Going back. Okay. So what's in the chat there, Kirby? I just saw something.
It was Macy saying the dreaded chain tool.
Yes, the dreaded chain tool. I will say that the latest version of the chain tool from Rev is more user-friendly than some of the others, but still it's really easy to overturn it and to pop out that pin. And as I learned the hard way, once that pin comes out, it's not going back in. So yeah, this is an excellent, very stable, has more torque, particularly if you add the 4 motors, really stable platform. It is a little bit more complicated. It can be harder to turn, particularly if you only have the 2 Omni wheels. It can get a bit easier if you add the other 2 Omnis there. So have any teams here ever used a 6-wheel tank drive? Okay. Kind of makes me wish Perspective was here, because they used a 6-wheel drive on Ultimate Goal to really good success. So, and I'm trying to think, does Black Forest use Mechanism or do they use 6-wheel this year? I can't remember. Which Black Forest is a top 25 team.
I can't
out of
remember, but I'm
Colorado.
going to find out.
Because I thought they might have used a 6-wheel, but I'm not entirely sure. So a lot of top tier competition teams have used 6-wheel drives because they're more stable. If you add the 2 more motors, they're more powerful. It's a really, really solid setup. Okay, so now this next one is a variation of a 6-wheel called the West Coast or Drop Center Drive. The big difference between this and the regular 6-wheel is that the center wheel on my robot, it would be this wheel, is dropped down a little bit lower than either end. You can use for the middle wheels, you definitely want traction wheels. And then you can use any combination of Omnis or traction wheels for the other 4 wheels, depending on what you want to do. Why do we drop down the center? Well, the big reason why is because it greatly lowers what's called the turning radius. So one thing that affects, and one of the reasons why the normal 6-wheel drive has a harder time turning is because the turning radius is pretty big. This tries to solve that problem by essentially making the turning radius just on these 2 wheels here. Okay. So it makes this much easier to turn. So it's a pretty solid combination of torque, speed, and it has that extra turning ability. Has anyone ever used a West Coast or a drop center drive?
I built one, but that was for first robotics challenge. I haven't actually.
Oh, so for FRC?
Yeah, but I built it. We just haven't.
You built it. Did you ever drive it?
No, it's not.
Aw.
The chassis is built. The programming, the wiring and stuff is not completed, so it hasn't been driven.
I see. That's a pity.
Vikram says he thinks a teammate is developing one or is looking to develop one.
Okay.
And it looks like Black Forest was using Mechanim.
Black Forest used Mechanim. Okay. I thought it might have been 6-wheel. Oh, well. Okay. So the biggest con with this one is it is a bit more complicated build. Now, particularly if you're going to build in a build system like Tetrix, it can be a little tricky to get the spacing right, particularly for that bottom wheel. Now, GoBuilda, if you use the GoBuilda system, they actually have ready-made spacers that allow you to build the West Coast. And, you know, even though I say it's a more complicated build, it's not that much more of a complicated build, but it does take some extra thought or extra resources. And this one can get stuck if you're not careful. So if you're driving over an obstacle with a West Coast drive, or you hit something and something gets under one of the wheels and the center wheels disengage, you're stuck. Okay. And you're just going to sit there spinning your wheels. And when I was researching this, I've seen competitions where a robot has run into a game element, like those little cubes for Rover Ruckus, which are coming back for this year's game. I've seen robots get stuck on those, and then they just spin their wheels for the entire time because they can't move, because they only have really the 2 points of contact with the ground, which are those two center wheels. So that's something you've got to be aware of if you're going to build a West Coast drive. And like Macy said before, there's trade-offs with everything. Okay, you get the shorter turning radius, but you have to be more careful to not get stuck on something. All right, any questions on that or additional comments? All right, I think we'll move on from West Coast then. All right, the system that almost all of us use, know, and love, the Mechanim drive, okay? So the idea is we're using 4 specialized wheels, the one with the rollers, that allows the robot to move in 8 directions without turning, okay? Now, unlike all of the other tank drives that we've talked about so far, this one absolutely must use 4 motors, okay? You can't run a 2-motor Mechanim drive, or at least I don't think you can. So requires 4 motors. The big pro, the reason why you go with Mechanim is if you want, or Mechanim, I've heard it pronounced both ways, tomato, tomato.
It goes both ways.
Yeah. So it is one of the most maneuverable chassis configurations out there, just because you can strafe in the 8 or move in the 8 directions without turning. And by the 8 directions, I mean forward, back, left, right, and then the 4 diagonals. So really, really excellent maneuverability. And that makes this one of the most popular choice, if not the most popular choice in competitive FTC. So how many teams, I've already kind of asked this question before. A lot of teams have already said they use Mechanim, so I don't think we'll go ahead and ask that question again. But a lot of teams have a lot of experience with Mechanim. So, but it does have its downsides. One is cost. Mechanism wheels often cost a lot more than your Omni or traction wheels. I think a set of Go Buildas is like 120 or 130. I think some of the other systems, I think Revs are like 99 or something like that. They were a little cheaper. I don't remember off the top of my head, but you are going to spend more money on these wheels if you're going to invest in Mechanism than you would with other systems. And some teams might not have the ability to do that. It's also more difficult to program. Okay, do we have any programmers with us that have programmed a Mechanism drive? I'm curious.
Yes.
Yes. Is it easy?
Once you know how to do it, yes. But trying to get it in the first place, it takes a lot of work, a lot of researching, a lot of learning how it works. But once you make it work, it's really easy after that, as long as you remember the right steps to get it working again.
Right.
Come a new year. So.
But compared to a tank drive, this is definitely next level programming from, say, a tank drive. Now, the nice thing is there's a lot of resources out there that can give you a base Mechanism drive, so you're not having to reinvent the wheel. Roadrunner, for example, which we're not going to get too much into Roadrunner today. But Roadrunner is a resource that actually comes in with a pre-built Mechanism drive program, so you can use that. But it's always better to not be able to understand the code that makes your robot go. Now, the Mechanism drive does require some trigonometry. It does require some sines and cosines. We're not going to get into that today. But just be aware that's part of it. So it sacrifices some speed and some torque. Okay, so in order to get that really great maneuverability, you are giving up something. Okay, they're not quite as fast, and they're not quite as able to, push other robots around if it comes to push and shove. The wheels also tend to be heavier. Although I'm curious with the Masters, since they said they use the V4s, what's the weight difference, do you think, between the V1s and the V4s?
I haven't actually touched the V1. We don't own them, so I'm not sure. The one we had before were the Handymark HD, which are really, really
those
heavy.
things are huge.
so these are so much smaller and lighter.
So, yeah. Also, Mechanism drives. This is another one, particularly for autonomous. You have to take into account your weight distribution. Not because you're worried about the robot tipping, because the robot, I don't know if I've ever seen a Mechanism robot tip in a competition. But it's more about being accurate in your autonomous movements. So making sure that you have that fine tuning. A lot of teams that use Mechanism will also pair it with something that helps them do odometry, just because those wheels do slip. Things like using dead wheel odometry, for example. Although, from what Corinne said earlier, maybe these newer generation ones are less prone to that. We're not going to get too much into odometry today. That's a topic that we could spend all day on, but it's not what we're going to get to.
They had to not drive too fast in autonomous to get them to be precise enough, but we had enough time in the 30 seconds to do everything. So
there you go. Great.
Now they do want to get into odometry for next year, so they are able to go
that's
faster,
something we'll probably save for next year's camp.
So, because one of the things to keep in mind with the Mechanism too is if you do use somebody else's template or something else like that, where it's, it's ready built code, instead of understanding or building your own code for driving the system, is when you go to do your autonomous, it's going to be harder to come up with your design principles. Now with Mechanim, it does allow you to keep a bot's orientation possibly easier to track, leveraging like the gyroscope or other stuff like that that's built into the driver station. You can, or into the robot controller, you can leverage that in means for being able to turn. Now that's also true for any of the other designs. As for like the stability of Mechanim, one of the things that make them very stable is that the wheels themselves are heavy, so it shifts your gravity, as well as the fact that they are large, typically large diameter, so there's more contact surface. But outside of that, they still are prone to, if you shift your center of gravity up and high, you're gonna flip or you're gonna tip. The other thing too with Mechanim is that they have a lot better traction than Omni Wheel, but they are still, they can still be pushed around, right? So if you're worried about a close contact game, being able to get to your destination with obstacles in your way, that's going to be an issue. The other thing too is that from a FTC judging perspective, Mechanim wheels have vector control in every direction. And so, the blocking, trapping rules are very specific, that if your bot has no vector of movement. Well, with Mechanim wheels, as long as there is a space big enough for your robot, you have a vector of movement. But sometimes Mechanim is not going to be the most advantageous for you as far as ref's judgment call on rules, or for situations where you want to be able to have larger control of an area. So there's lots of give and takes, right? Mechanim is going to give you the most amount of control as far as maneuverability, but there's lots of other losses. And so it all comes down to, what is your design? What are you trying to accomplish with it? So it's like, we're talking about chassis, but also keep in mind everything else that has to sit on top of your chassis, or what the objective of your robot is, because that also needs to reflect on what your chassis is going to be.
Yep. Absolutely. And I'm really glad you brought up, I wouldn't have thought of the ref penalty, getting pinned or blocked. And I will say that, one of the things that my team experienced, both of my teams from last year experienced, is when lining up to shoot for ultimate goal, our robots got pushed around pretty easily. Got pushed out of alignment a little bit.
Yeah, ultimate goal, I would say, was not the best game for Mechanim, because you're trying to get rings, which is trying to funnel stuff into your intake, right? So Mechanim is great for being able to position and turn and rotate yourself, but if you have really well designed four-wheel drive, you can accomplish the same thing. Or even just doing, two wheels drive, you can accomplish a lot of really great things by autonomizing your drive. So if you put in, a button does a 90-degree turn in a direction, you double tap it, that's 180, right? And have 360-degree turns with a button. You can get your bot to be more maneuverable than a Mechanim drive by helping your drivers have autonomized actions, right? And then you're talking about a level of programming to put in the autonomization for a tank drive system is far less than the automation of a Mechanim drive. And so, your level of entry on the programming side becomes a lot easier. And if you're a team that you have to leverage, okay, we have X amount of hours, where do you want to dedicate those hours to? And it really comes to resource management. The other thing is, pretty much every drive system you can have do with 2 motors. You have a resource limitation of only 8 motors. Where are you going to put 8 motors? Well, if you use Mechanim, you have just lost half of your available motors. So if you wanted to use 5 motors for an intake launching system, you're out of luck. So there's lots of things to keep in mind as you do this resource management, as you design and build your robot.
Yep. All right. Any other questions or comments about Mechanim? I mean, one thing I hope that you come away with this is that Mechanim is not the end all and be all chassis. Which I feel like a lot of teams in FTC have kind of made Mechanim the end all and be all, and really it's not. There are a lot of other solid options that you can try. Okay, another type of drive, which I think I saw a few robots at State that did this, the X Drive. X Drive, you're essentially using 4 Omni wheels at 45-degree angles. And like Mechanim, it does require 1 motor for each wheel. The pros for this is extremely maneuverable, similar or even a little bit better than Mechanim Drive, because one of the things that I found out in researching this, Mechanims are, due to the design of the wheel, are limited in how fast they can strafe left and right. Okay. This configuration, the X Drive, you can actually go faster going strafing left and right than you do with Mechanim wheels. So this is an extremely maneuverable drive setup. Doesn't require the more expensive Mechanim wheels. The wheels are lighter, okay, which can be a good thing and a bad thing, depending on exactly what you want out of your drive. It has a similar programming kind of thing to it. Just out of curiosity, has anyone here ever used an X Drive? Trying to think of. I thought there was 1 or 2 teams. Kirby and Nick back me up on this, but I thought there was at least 1 or 2 teams that used an X Drive at State, and I'm trying to think of who they were.
I can't think of any this year. I've seen them in past years though.
Okay.
I think we had a few throughout the season. I don't know if they were at State, but
that might be.
I don't recall what the teams are either. But yes, X Drive is one of the more common things. A lot of teams will, they start off with a tank drive and then they're like, well, we have all these Omni wheels.
Mm-hmm.
And they're not super expensive to get, right? So then they attempt to do this X Drive. And the X Drive is a fantastic step in progression, right? It gives you far more options and can give you the amount of maneuverability and everything else. And it can be a great stepping stone for increasing your programming. It gives a great challenge to your team because you now have to build something at odd angles. It can't just be a straight chassis in a square, right? So now you have to actually design a chassis that has these 45-degree offsets. You then also have to have programming that is going to independently control 4 different motors depending upon how your joysticks are done. And you have options on how you want to program it. Like in the graphic shown on the slide, we have one joystick does movement and one joystick does strafing. And it's like, you can customize that all you want in programming. So this gives you a great experimental step for being able to see what all you can leverage with that interface between programming and hardware. And one of the things you'll notice is a lot of teams that excel within FTC, and this is kind of across the board, are the ones that are able to see the software layer and the hardware layer as not separate entities, but as things that assist each other. And so this X Drive is a great example of where you have a hardware that is able to move in any direction because physics, and you take software to enable that to work for you in a great way. And this is one of those systems where you can set up encoders or something else that does position tracking with your motors and get very fine and excellent control of your autonomous. The other thing is with this is probably even easier than Mechanim is being able to get, if you're using either computer vision or anything else like that to do position tracking on the field, this allows you to, if you put it into an autonomous program to do those adjustments, the robot could definitely move in very strange and mysterious ways because it can move in any direction, but that could be beneficial and you can leverage that where I need to be exactly positioned between these 3 different targets, right? So you're doing a triangle, you know, trigonometry basically there to get a exact position with 3 source points. But your robot could do that automatically once you get that programmed, and it'll do circles or whatever else to get to that exact point. And so it can be very, it's one of those extra is one of those that gives you a lot of options.
Yeah, it gives you a lot of options for not a lot of price, for a lot of things that a lot of teams already have. So,
Laurel says plus or minus used it 3 years in a row back in the day.
Okay. Yep. So again, just like all of these others, there's some cons here. The biggest one is xDrive does not have a lot of traction. This probably wouldn't have been a great idea for Ultimate Goal, come to think of it, just because of getting pushed out of the way when fighting for places to shoot for the goal. So the game manual 0 actually says it's fast enough to avoid getting pushed, which I guess is true. But then when you're all lining up in the same place, particularly now, if you've thought it out, there are ways around it. You can think around it and say, okay, well, everybody wants to line up right in front of the goal. What if we did this at an angle where robots are less likely to be? There are ways around, to think around that, but it is something you have to take into account. And the programming is a bit more, it's more complex compared to Tank Drive, but I think Nick made an excellent point in saying that it is an excellent step up for teams that want to take their programming to the next level. All right. We've got a few more train drives to go through. And I think what we'll do is, I think once we finish our discussion of all the popular chassis configurations, I think we'll go ahead and break for lunch. So we'll go ahead and just move on here, because I think I've only got 2 more on here. So this next one, this is called the H drive. The H drive uses 4 Omni wheels like a tank, so you can like there, but then it adds this 5th wheel in the center. Okay, sometimes H drivers can even use 2 wheels in the center. Okay, that you can do this either with 3 motors, where you can have essentially, you can chain drive 2 on the left, 2 on the right, and then 1 motor for the center. Or you can do 5 motors. If you wanted to get real crazy, you could do 6, but I wouldn't recommend that because that leaves only 2 motors for all your other contraptions and mechanisms. So what this does, this is kind of a middle ground between Mechanim and Tank, because it allows you to strafe like both the xDrive and Mechanim will do, while not being as easy to push around as either Mechanim or an xDrive is. Just because if someone tries to push you from the side, you can somewhat push back by powering that center motor here. It's not quite as maneuverable as some of the others, but it does have some good options here. This is one of your more exotic drives. I've seen more of these in FRC than I have in FTC, to be quite honest. I can't think of too many H drives even out there on the internet. I found one example of an H drive that a team used down in Texas. I can't remember what the name of the team was, but it's not quite as common as a lot of the others that we've already talked about today. Some of the cons, it's more complicated. One of the big ones is it gives up a lot of space in the middle because you have to have the wheels there, you have to have the motors there, or you have to have the mechanism to transmit the power from your motors there. And a lot of robots use that space in the middle for different things. I mean, think about Skystone, where a lot of teams had just a lot of their things on the side and they had an open middle so they could use that for an intake system and intake blocks through them. Again, it's not an insurmountable problem, but it is something that has to be taken into account. Also, while this guy can strafe, it's not going to be as fast or as effective as it will be with a Mechanim or X drive. I don't know if anyone here has used one. I'm going to ask the question anyway. Anybody used an H drive before?
I certainly have never seen one.
You've never seen one.
I've seen it a couple times.
Yeah. Again, I've seen it a few times in FRC. I've seen it like once in FTC. So if you want to do something different, here it is, but you need to make sure that you have the reason. You don't want to do something different just because it's different. You need to make sure that you have a good strategic reason to use a drive like this.
The times that I've seen this used is for when, like with Ultimate Goal, if a robot needed to go side to side to line up with something, that this allowed for teams to do that with good precision of being able to just strafe side to side. But other than that, it does not give you a lot of benefits. I have also seen teams where they will shift the H drive instead of being in the center for strafing, they will put it on one of the back, either the back or the front, and leverage it actually for rotating their bot. And so it gives you different options for what you're trying to accomplish, right? So it really just depends.
Yeah. I would give this one, I would think very long and hard before I ever used an H drive, to be quite honest. Doesn't mean you can't do it, but I think there are things that do what this does better.
Again, it comes down to what resources you have, what resources you're looking to do, and what you're trying to accomplish, right? So,
absolutely.
You know, realistically, to accomplish an H drive like this, you kind of already have to have the amount of parts for an X drive. So do you have the programming resources and time to make X drive work? That's going to probably work better for you. Do you have the resources for Mechanim? Mechanim is going to probably work better than this. So there's a lot of alternatives for what this is efficient at for that can be accomplished other ways. That doesn't make this invalid though.
No, it doesn't make it invalid. You just need to make sure that you have a very solid reason to use this over others. So anyway, last one, I'm going to mention it. I'm not going to spend too much time on it. The swerve drive. Swerve drive. This is where you use the motors to both power the wheels and also you physically turn the wheels in whatever direction you want them to go. This is by far the most complicated drive we'll talk about today, and even then, I'm not going to touch too much on it. The reason why teams want to do this, and by the way, the only teams I've seen use a swerve drive and used it effectively are like world-class teams. So things like gluten-free, okay? Gluten-free has their differential swerve drive and things like that. Teams that are at the top levels of FTC. because the swerve drive, it takes a lot of resources, takes a lot of engineering know-how, it takes a lot of maintenance. This drive just takes a lot. It is an extremely complicated drive. It's also a challenge to program. And the thing is, in FTC, again, because we only have 8 motors, people that want to design a swerve drive are left with either doing 4 motors and then dedicating 4 servos to actually turn that, like this configuration here, or they have to do something like a differential swerve drive like gluten-free did, that allows them to control both the spinning of the wheels and the direction those motors spin. But doing all of that is extremely, extremely complicated. And the thing is, I include this in this presentation because I knew if I didn't include it, I knew one of the members of my team would ask about it. I knew this question was coming. So I would say for the majority of FTC teams out there, unless you have the resources, unless you have the time, you almost have to, I would recommend, if you were to try a swerve drive, you would almost need an entire summer just working on a swerve drive before you get on that. And if you're willing to put in those kind of things, great. But if you get to September when the game is announced and you're like, oh, we want to do a swerve drive, I really wouldn't, because you're going to lose a lot of time on practicing driving your robot, building the other components and all those things, on working on your swerve drive. And it does you no good to have an excellent swerve drive and be behind on everything else as you get to your first qualifier. So this is for teams that really, really want a challenge, but they really need to be up to that challenge. So Nick, I think you probably have some things to say about this. So
I've faced off against drive teams when I competed in first in California. They can be used to great effect, but also I don't think making it is the hardest part, because it's simply getting the hard part can be getting the needed wheels designs for it that have it, but it's essentially also eating up your wheel and servo resources, because you need to have 4 servos. It can be used to great effect. The one that I faced off against was with Block Party, and so they were able to just drive over, because you automatically get kind of a height boost with this because you need height for all of the things that take place. And so they basically made a stilt bot where it could just go anywhere they needed it to, because it was 3 inches off the ground, so it went over any obstacles. And it worked pretty well, but it wasn't the fastest thing out there, and it wasn't the most maneuverable, but it gave you some pretty cool and unique options.
Yeah.
The hardest part, I think, of it properly taking advantage of them is having your dry team be in proper sync or leveraging automation to help make it possible, because you're now having to drive 2 different things: the direction of the robot via controlling the wheels and the direction of the robot via the wheels. And so being able to create automation that makes that easier, or having a drive team that is highly in sync. The teams that I faced off with, the hard part wasn't the creating of the mechanism itself. It was making sure that you were able to leverage it in an appropriate fashion.
Yeah. Now this is the traditional swerve drive configuration. The gluten-free version, which was the differential drive, was actually really low to the ground, because they found a way they had a bunch of gear systems that they could use to spin it there, which they didn't have to use the 4 servos. but boy, those gears are complicated they put in there. And they also, according to Gluten Free, they also broke. They had to make custom gears for that, and they broke really easily. Again, you really want a challenge, but in my opinion, it's not, unless you're a top tier engineer in FTC, I just don't think you get your bang up for your buck out of a swerve drive. I don't think you get that highly superior thing out of it for as much effort as it takes to build, program, drive, and all those kind of things. I don't see the bang for your buck there, to be quite honest. And that's why I just say it's not recommended for most FTC teams. So, all right, I think that gets us to all of the, and these are all of the most common chassis configurations. And I even threw in two of some of the more exotic ones. I hope this has given you some ideas, some things to think about when you're thinking about that. You're not just automatically pushing the mechanism button and saying, oh, what chassis we're going to use? Oh, mechanism, because that's what everybody else uses. I hope this has given you more options, more things to think about and go, well, is mechanism really the best drivetrain or configuration for this game? And for Ultimate Goal, it wasn't. It really wasn't, even though so many teams did. Now, it doesn't mean that teams with a mechanism wheel couldn't be successful in it, because there are plenty of them that were, but there might have been some other better options. And that's largely the reason why we're doing this, is we want to open your folks' minds to all of the different options that are available in FTC. Okay, well, it is 11:53. I think now is as good a time as any to take a lunch break before we continue our discussions here.
Before we do that, I'm going to put Discord links in the chat again. We've only got, out of 15 people here, only 3 have joined and entered responses on the form. That, of course, is not counting myself, Leif, Laurel, and Macy, because we were already on.
Mm-hmm. Yep, so go ahead, take this lunchtime to go ahead, get signed up for the Discord. If you have any questions, we're right here to help. So what do you folks say we take half an hour for lunch? So we'll resume our discussion of drivetrains and all that in about 30 minutes, so about 12:30. Does that work for everybody?
Works for me.
Yep.
Okay.
Grim says yes.
Great. So go ahead, grab a bite to eat. Now, if you want to get on the Discord and start maybe chatting with your alliance partners about some of the things, maybe what kind of chassis you want to try for your different events, which, by the way, don't use mechanism for the robot climb. Don't do it. Or an X drive. Don't do it. It's not, you're not going to do as well as you could have with others. So don't just push the mechanism button. Okay.
Please note, even when you do join the Discord, I need that form filled out as well, so I can assign the proper roles to you for this entire camp series. So
Okay.
make sure to follow both of those links.
Well, I think we'll go ahead and get resumed here, or start getting resumed here. Hopefully the folks that haven't returned yet will pop back in before too long. But I guess one question I'll ask, and you can either say your answers out loud or type them in chat, just like what we've been doing. What have you thought about what we've talked about so far? Has it been helpful? Has it maybe not been helpful? What kind of things do you want to learn more about? Some of these things. What have you thought about what we've discussed so far?
Now, I didn't realize how many different kinds of drivetrains there were.
Yes, indeed.
There's a lot, isn't there?
Yeah.
Thing is, we all just want to push the mechanism button, right? Because that's what we've been conditioned to do. But there's a lot more options than that. Okay, any other thoughts about what we've talked about so far? Yes, no, maybe?
Nothing in chat.
Okay. Well, I'm going to be asking for feedback a lot during this camp, mostly because this is the first time we're doing this. And we want to, we want to improve it for future workshops, both this year and for years to come. So if you ever have any comments, any feedback you want to give us, you can email me, you can email Laurel.
I'm creating a channel in Discord specifically for feedback as well.
Oh, that's a great idea.
Beating me to it. I was just about to do that myself.
So, because we want this to be the best. We want this to be effective for you folks. I know I've learned a lot in researching all this, but one of the things, I'm a career teacher, and one of the things I've learned is that the teacher almost always learns more than their student. It's when they're putting together things. So this has been greatly helpful for me as well. All right, well, I will share my screen and let's get back to it. Okay, so now that we've talked about the configurations, the next bit, we're going to talk about the different types of build systems. What I mean by this is what are the kits and things that are available out there, along with custom options. So here we go. So first thing is in FTC, and this is one of the reasons why I really like FTC, is because there are many different build systems out there. There's not just one system that you have to use to build your robots. There's a lot of different options for you. You can do Rev, you can do Tetrix, you can do GoBuilda, you can do Actibotics, or you can do your own thing. There's a lot of freedom in FTC in what kind of things you can choose to build your robots out of. Of course, that means that when there's a lot of options, it's like going to the grocery store and you're like, okay, I'm going to go buy some rice. And there's like 10 different brands of rice. And you're like, and some rice is great for stir fry and others are great for when you just want a pot of rice, I guess. I don't know. Some is better for sushi. I don't know why I thought of rice, but that's what came to my mind. But yeah, it's just finding the right kit for you. Or if you'd rather go off and try to do your own thing, that's also an option. Okay, so a quick note, and this is very similar to what we talked about when we talked about the different chassis configurations, is you can have success in FTC using any of these systems. So again, it's like you don't just push the mechanism button and win. Okay, with the chassis configurations. Also, there's not one build system that is so superior to the others that it just wins all the time. And that includes custom chassis. I've known a few teams that have done custom chassis that have done really, really well and have gotten to Worlds. And then I've known people that have used like the same Tetrix kit they've had for like 7 years and get to Worlds. So you don't have to use a particular system or make a completely custom system to have success in FTC. You just don't. And don't let anybody tell you otherwise. But whatever system you do decide to choose, make sure that your team has the resources, ability, and time to make the most of that system. So if you're going into next season into what's the name of the game this year? Gosh dang it. I just had it and I
Freight
lost it.
Frenzy.
Freight Frenzy. Yeah, you're going into Freight Frenzy and you're like, oh yeah, we're gonna make a custom chassis and it's gonna be awesome. And then you spend all of your season building your custom chassis so that a month out of your first qualifier, yeah, you finish your chassis, but you have nothing else done. That's probably not going to end well for you. Okay. So make sure you take the time and plan out the time to do all those kind of things. Okay, let's start with Tetrix. Boy, oh boy, oh boy, oh boy, oh boy. I still want to hold to what I just said, and that is that you can have success using a Tetrix system. There are some top tier robots that use Tetrix systems or have Tetrix bases. But out of all the kits I've tried, and which by the way, the 3 kits I've tried are Tetrix, Rev, and GoBuilda. So I have experience with all 3 of those systems. Tetrix is by far my least favorite of the 3. That's my own opinion, putting that out there. It is one of the kits that you can buy directly from First when you register your team. It's not too expensive, which is a good thing, particularly for teams that are starting out. And in all fairness to it, it is a pretty intuitive system in most ways. Okay, it's a pretty simple to use system. The channel is nice. Getting your spacing is pretty easy with Tetrix. Mounting your motors, all those things. It's a pretty user-friendly kit. But here's where I really don't like Tetrix. It really is, I feel, considerably lower quality than a lot of the other options on the market, particularly Rev and GoBuilda. Do not, if you decide to use Tetrix, that's fine, but do not use the nuts that come with the Tetrix kit. Those nuts, I still find those nuts in the back of my car where I've driven the robot for my students around. I still find them. Those nuts do not stay on.
My kids use those nuts to make earrings. You will see my daughters at tournament wearing earrings with cap nuts on them. This is all they are good for.
Exactly. Yeah. Hot glue them together, use them for art projects. Just don't use them for robotics because they're not good. They do not hold on very well at all. Now, if you do have a Tetrix kit and you're like, oh no, don't worry. You can buy Nylox, which I've got some recommendations toward the end here. You can buy the better nuts and they're not too expensive. And I would recommend that you do so because the Tetrix nuts don't stay on. And the lower quality goes to more than just the nuts. The channel is easier to bend than a lot of the others. It's not as sturdy. Some of their side kits, like their rack and pinion system, the fact that they made a rack and pinion system out of plastic, just why? I mean, it's cheap. It's cheap, but boy, does it wear out very quickly. It doesn't work. It doesn't play nice with a lot of the other systems. Supposedly, Tetrix is supposed to be able to work with GoBuilda. I will tell you from my team's experience, it's still a pain to get Tetrix and GoBuilda holes to line up in the ways that you want them to. I would say if you've got Tetrix, yes, you can make it work. Yes, you can make a very high quality robot. Yes, you can compete. But if you have a choice, particularly if you're starting out. Now, unfortunately, there's no rookie teams here, but if I were to have a choice of which kit I would go, Tetrix would be my last choice of the three, just because it just is not, in my opinion, is not as high quality as your other options out there. Does anybody else have any thoughts about Tetrix? Have used Tetrix before and want to give their 2 cents on it?
I know the teams that I worked with in the past had a lot of trouble with specifying, well, I'm wording this wrong. You can see all the holes that you can slip bolts and nuts through and put it together, but you're limited to those particular holes. So if you have a measurement that's halfway between, either you're out of luck or you have to drill another hole. On the other
Which I
hand,
really wouldn't drill holes in this with as weak as that aluminum is, I wouldn't drill holes in it.
yeah. I mean, if you put it together right, it can be a pretty strong chassis, but it does have its limitations.
Yeah.
One
Well,
of the nice
I will say that with Tetrix just being extruded aluminum based, it is very easy to modify and to build on. Yeah, it's somewhat weak, but you can double layer parts or whatever else to get there. So with it being just extruded aluminum, it's very easy to add holes where you need to, or to cut it with a bandsaw or a hacksaw or just about any saw. So it is actually very easy to manipulate and to work with, and it's very inexpensive. It also, with the variance of holes, if you want to buy raw materials, like you want to just buy some aluminum flat bar, you can buy some aluminum flat bar and use Tetrix as a template for drilling holes into the flat bar to make it line up. So you can buy better build systems, but with Tetrix being very just simple extruded things, it's inexpensive. If you mess it up, it's not like, oh crap, you can just buy another one. So it is it's not the end of the world if you have Tetrix. You can still build a lot of stuff with Tetrix, and it can give you a good foundation for understanding how basic build principles work, for being able to go outside of a build system and get your own materials straight off a shelf or from Amazon or wherever else to help make those custom parts you need. That was something that my robotics team did a lot, is we had the Tetrix starter kit, but we built a lot of our own stuff using acrylic or using flat bar or L channel that you can just buy on Amazon. And, with a hand drill and a hacksaw, you can do a lot of fun modifications with Tetrix and getting that to work with, COS, right? Parts off the shelf. So.
Yep.
I was just going to add the one thing. We have Tetrix too, because when I started 7 years ago, that's what there was. One thing that needs to be replaced too is the hubs, because they're just round and it's just a set screw. So before we started buying GoBuilder, we replaced them with the HandyMark knobs, which have actually that are D-shaped holes. So at least the axles do not just start turning randomly.
Yep.
I know from our experience between Rev and Tetrix, the one nice thing about Tetrix was they had metal gears, where Rev in their starter kit, it was plastic. We kept stripping out our plastic gears on the shafts, or they broke a lot easier than the metal ones. So that was one nice thing about Tetrix. But a lot of the other stuff we didn't like as much, but the gears were nice because they were metal, so they were a lot harder to break.
I have no idea why Rev decided to go with plastic gears, but yeah, that's a very good point. Anybody else want to talk about their experiences with Tetrix? Okay. Well, for a long time, and again, I've kind of badmouthed Tetrix a little bit, and maybe it's not as I don't think it deserves that. It's just out of the systems I've used, it's definitely my least favorite. But if you're willing to work on it and you're willing to replace some certain key things, the nuts for sure, you can make it work. You can make it work. You can combine it with off-the-shelf things, as Macy discussed here. You can, and again, there are world-class teams that use Tetrix. And you can make it to work. You don't have to throw away your Tetrix kit. But it's certainly not my first choice. Okay, moving on. Rev, the kit I got from Laurel to play around with, which again, thanks Laurel, this summer is the Rev Starter Kit V3. But my team has used Rev considerably for the last few seasons. We've kind of used it just in, full disclosure, our team, or the teams that I've coached, have primarily, one team used a combination of GoBuilda, Tetrix, and Vex, which in hindsight, maybe I wouldn't mix those systems in the future because they really don't play nice with each other. Yeah, Vikram says that was very interesting, which, yeah, that's talking about the other team. Whereas the other team used a combination of GoBuilda and Rev, and in all honesty, these systems actually work surprisingly well together. One of my lead builders, who unfortunately is not here, Travis, found a way to modify the GoBuilda strafer chassis, essentially put Rev extrusions all along the sides of it, and then we were able to just build on top of it as if it was a Rev system. So that's one of the reasons why I like Rev quite a bit, is it actually works pretty well with a lot of other systems. It has a lot of flexibility. It's very modular, very easy to, my team, you've got the extruded aluminum, and it's, all you need is a shop to go cut it to whatever size you need to. Also, the one thing I think that Rev does better than even GoBuilda or anybody else is their motors. I think the Rev Ultraplanetary motor, which we'll talk about later on, is probably the best bang for your buck on the market in FTC right now. Just because most motors, and we'll get to motors later on, most motors come with a set gear ratio, or you have to buy different gearboxes to put on there if you want to change the gear ratio. Whereas the Ultraplanetaries, you've got clips where you can change a motor from a 3-to-1 to up to a 125-to-1 with just a few clicks. So I really love their motor system. I'm glad that Rev has gotten some channel, because before it used to be just the extruded aluminum. Let me grab my little robot here. So you can see in the newer versions of Rev, they have started using some channel in what they're doing, which I think has helped in what you can do with it's made it a little more user-friendly, in my opinion. So I'm glad that they made that move. But no build system is perfect. Someone mentioned the plastic gears. I don't get that move. You certainly shouldn't use plastic gears on a drivetrain, in my opinion. I think you have to, or on something that has a heavy load. I mean, there are places where you can use plastic gears, but
Yeah, so something I saw at Park City, we had the team from California that had originally come out to volunteer. That robot being built quickly was using, I think, acrylic gears. And I remember at one point or a few points, I ended up walking out onto the field just to pick up pieces of those gears.
Acrylic is a really bad plastic to
Yeah, they
make
were
something like
3D
gears
printed
out of.
gears. So
Yeah.
it was so they had acrylic gears that were laser cut, and then I think they also had some 3D printed gears that were out of ABS. Both just don't have the strength necessary for teeth based gears. That's why it's like if you're going to 3D print gears, you use planetary
Yeah.
styles, right? Because it can actually take that force. Because plastic does not have a great shear strength.
No. We're actually going to talk about planetaries later on when we get to motors. The difference between spur and planetaries. But yeah, anybody want to talk about their experiences with Rev?
I liked it a lot better in Tetrix. It made it was a lot easier to adapt. And when doing things with like spinning axles and things, they're hex bore ones where you can stick the shaft straight through it. That was really easy because then you could mount the motor pretty much anywhere. You could just have the shaft going straight through it, and just as long as you're at a place that it wouldn't lift up weirdly, hold it down, it could sit and spin that shaft. And it could spin a whole bunch of things along that shaft with only having it attached in one place through, and it could go through the motor, so the motor could be in the center of the shaft and things. And so that was really good. But one thing I'd recommend if doing Rev is try and go and purchase metal gears, because they do have metal gears, they just don't come in their starter kit. So you have to go and purchase them on the side. So that's something I would suggest doing, because then you're less likely to break them. They will break still if you put too much force and things on them, but they're a lot harder to break than these and strip than these plastic ones.
Okay. Anybody else that has experience with Rev that wants to talk about it? All right. I think Rev is a solid choice, I think, for a team just starting out. Again, you might want to replace a couple of things, but I think it's a very nice, versatile system. It's not as expensive as some of the other ones are, particularly things like Actobotics or even GoBuilda. I think if I were to choose one kit between Tetrix, Rev, and GoBuilda, if I were to only get one kit, just their starter kit for a rookie team, my choice would be Rev. GoBuilda, which we'll get to in a moment, has some great things, but really to make the most of it, you really have to spend some money to get some of their more advanced stuff, in my opinion. I think for a starter kit, Rev is probably the best bang for your buck. Hashtag not sponsored. I wish I was. Okay, so yeah, any questions about that? Okay. And then third and finally, the new kid on the block, GoBuilda. So this is the newest system. For those of you that have been around a bit longer, GoBuilda grew out of, it essentially came out of the Actobotics. The people that founded GoBuilda came out of Actobotics and decided to build a system specifically for FTC that was user-friendly. So it's a relative newcomer. It's only been around for what, 3-4 years? So, and one of the nice things about it is, unlike the other two systems, GoBuilda was made with FTC specifically in mind, built by people who have experience in FTC. The Go Build a channel is huge compared to a lot of the others. If you hold up a piece of Go Build a channel and compare it to, say, Tetrix, Go Build a channel is huge, which there are good things about it. One is you can fit motors inside it. In fact, a lot of their strafer kits are designed so that the motors fit inside the chassis. But one of the things that we've struggled with is Go Builda tends to skirt that line around that 18 by 18 by 18 starting size a little bit too much. They really don't leave a lot of room for error with the Go Builda chassis. And so unless you really have to be careful when you add things to this that your robot can still fit inside the box. So it has a hole pattern that's supposedly supposed to work well with a lot of other systems. I will tell you it works well with Rev. Again, the Mechanites, added Rev extrusions to it, and were able to build a nice box. Which, in all fairness, with the extrusions, you could almost do that you could use that with Tetrix or any other channel system. I will say I wouldn't recommend pairing this with Go Builda with Tetrix. It can be done, but it really limits where your things can go, and it can be I will tell you just from personal experience, it's a pain to get things where you want it to be when you try to put Go Builda together with Tetrix. It doesn't work as well as I would like it to. Just be aware of that. One of the good and bad things about Go Builda is Go Builda, particularly since they're such a new company, they've been constantly updating their parts. They've been constantly updating their motors and their wheels and things like that. And the thing is, that's both good and bad. Because really, I've got the Go Builda V1 chassis with the old Mechanism wheels. And we only got them 2 seasons ago, and they're already outdated. Like, I can't buy them anymore because they're out of stock because Go Builda's moved on to the V4s. Which I will tell you, do I need to buy the new ones? No. The ones I have work just fine. But it's a little irksome to buy something brand new only to have it get outdated within a couple of years. So, plus, the thing is, my teams like to dye the colors of the wheels for different things. And that was possible with the V1s. And now that whole system is already gone. Like, you can't buy the blank wheels anymore because they don't make them. So don't get me wrong, Go Builda is a very solid system. It's a very trendy system. You'll see a lot of teams out there use the Go Builda system, and they've been really active in trying to promote themselves to the FTC community. And they've gotten a lot of love from the FTC community because it's built for FTC. But it's not, it's like the Mechanism button. You're like, I have Go Builda, I win. No. There are plenty of Go Builda bots that get beaten by Tetrix bots. Because at the end of the day, it's not necessarily the system that will win you a competition. It's the engineering know-how. It's the way it was constructed, there are a lot of factors that can way overpower the company that you choose. The other thing with Go Builda is I feel like with their base kit is missing a few things, I think. We've had to buy a few things on the side to get things like basic things that we've wanted. And for as expensive as that thing is, there's a lot of things in there, and there's things that we never used. And there's a lot of things that we ended up having to buy because it wasn't in the base kit. So that's one of my frustrations with GoBuilder. So great. I mean, don't get me wrong, great system, but certainly not a perfect system. Anybody want to give their 2 cents on GoBuilder or using GoBuilder?
Use their newer motors for their drivetrains. Their older
Yes.
versions had plastic gears. And if you're using the older versions, make sure you have extras, because if your wheel gets stuck at all or anything and can't rotate, your gears are going to snap.
Yep.
So, and the newer ones now have metal gears, which I don't know why you would put plastic gears really in a motor anyways either. But they now have metal, so they're going to be a lot harder to break. But it's nice to also make sure you have extras, because things do get stuck easily.
Yeah, wholeheartedly agree with that. And we've run into that problem. I'm glad you said that. Yeah, Vikram from my team said the width of the kit. Yeah. So again, it puts you right up against that 18 by 18 by 18. And it leaves like maybe a few, a centimeter or two, which not ideal. Anything else?
I just want to say, from GoBuilder and Actobiotics sells those too. They have servo blocks.
Yes.
And the only time my team broke a servo was the one servo that didn't have a servo block on it, because especially the GoBuilder one are gigantic. But if you get the Actobiotics one, they are more reasonable size. And those are great.
Yes.
As far as just GoBuilder in general, what I like is the motor are a lot easier to mount, and the motor mount are a lot more secure than anything from Tetrix or Rev.
Yep. Those are all great points. Servo blocks. Yeah. And I actually, the thing is, I like the Rev motors a bit better than the GoBuilder ones, but I like the GoBuilder servos and the servo setups a bit better than the Rev. So I'm kind of split on those. My own personal opinion. But the servo blocks, being able to support that, yeah. Any other thoughts? Okay, one more system then before we get to the custom. Andy Mark. Okay, I actually have one of those that Laurel has been kind enough to lend to me for this. Let me go grab it. Okay, here it is. Okay, so Andy Mark has their own kit, but they really push this Tile Runner series. Now, I don't know how old this particular version of the Tile Runner is. And they're doing constant updates as well. One of the nice things about Andy Mark is a lot of their chassis, including the drop center, like the West Coast Drive, they've essentially already just done the design work for you. In putting together many of the different types of chassis alignments that we've talked about, whether that be a mechanism drive, whether that be a 6-wheel drive, whether that be a West Coast drive. Andy Mark kind of takes some of that design work off of you for a price. Andy Mark, these things are expensive. I just checked before I hopped on here for a 6-wheel drive, just the Tile Runner and things like that. That's $600. which that doesn't come, that just comes with the tile runner and the 4 motors, and that's it. That's all you get. You don't get any of the other things. Whereas you can get a Tetrix or a Rev or even a Go Build a Kit for less than that. So this is for teams that, you know, have the financial means to do that. Okay. This one is definitely one of the more, you know, more expensive options. It's adaptable. It's pretty, you know, it's easy. But then again, you know, part of me wants to say that it's almost too easy in a way. And it robs students of the experience of designing and putting things together themselves. On the other hand, you could also say, well, it frees up more time for them to do, you know, the other, you know, you don't have to spend all this time working on a chassis when you've got one that's already built, already reliable, already well tested. You already know it's going to do well. So you can spend your time on the other parts of that year's game. You can spend more time on, if we were to do Ultimate Goal again, on the shooting mechanism or the intake system or other things. Again, there's balance here between you're saying, okay, I'm not going to learn as much about the chassis system, but I am getting a reliable chassis. But boy, am I paying for it, because these things, again, aren't cheap. Some of the more expensive tile runner configurations can easily run you over $1,000. And a lot of teams don't have that kind of money sitting around. So that makes it difficult for a lot of teams, particularly teams that are just trying to get off the ground. This is a tough option, because most teams simply can't afford it to start off with. Anybody have any experience using Andy Mark? And I think part of the reason why not a lot of people use Andy Mark again is because it's expensive.
Yes, we have parts. We have Andy Mark parts, like we have wheels,
yes,
motors, but not the tile runner chassis, right?
Yeah. Which I'm glad you reminded me of that, because the compliant wheels,
yes,
the green wheels from Andy Mark are some of the best ones out there. They're great for things like shooters or intakes. But yeah, I probably wouldn't recommend going and getting a tile runner, just because of how expensive it is. All right, then you have custom options, okay? Now in FTC, your team has the option to not use a kit, okay? And create your own custom chassis. Now, a lot of even custom chassis will still use parts for one or more systems. So you don't have to completely reinvent the wheel, okay? Now, if your team has access to some tools, you could use things like laser cutters, water jets, or CNC machines to make your own designs. And the thing is, you could say to yourself, well, I don't have access to any of that. Or I don't have like a school shop or things like that. I'm a homeschool group or something like that. Well, here's the thing, and here's how some teams have gotten around that. One thing that's popped up around the state of Utah, along with a lot of other places around the country and the world, are things called maker spaces, where for a fee, you could go in and use a laser cutter or a water jet, okay? You could partner with a company. You don't have to own a laser cutter or a water jet or a CNC to be able to use it on your robot.
Laith?
Yeah.
Sorry to interrupt. There is a makerspace that is open to FTC teams, FLL teams, and FRC teams in Salt Lake City. And they are actually planning now to have a full FTC competition set set up
Ooh.
in their space for the entire season. And that is for you guys. You guys can schedule and go in and use the space.
Excellent.
I will get that address out in a later email. But be watching for that and know that it's coming.
Excellent. So yeah, so you don't have to I didn't know about that, but we've actually worked with a makerspace here in Provo that's sponsored us on some things.
This option just came through yesterday.
Oh,
So
did it? Oh, great.
Brand new information.
Hot off the presses. You heard it here first, folks. So yeah, my team has partnered with some maker spaces in Provo. I think the Masters a couple years ago, if I recall, partnered with a water jet to do a custom chassis. If I remember
Yes, there was
correctly.
a makerspace in Provo, but I think they moved. The people who were running it moved out of state,
Yeah.
so that one doesn't exist anymore. And
Yeah.
that was
One of the things to keep in mind too is outside of just maker spaces, you can also contact, engineering or manufacturing firms within your cities or your area. And a lot of times they can, if it's like, hey, they have CNC machines. A lot of times, for sponsorship, they are glad to be able to sneak a part in every once in a while. Just keep in mind when you do those kind of relationships that it needs to be something that you're going to do, like you've tested with prototypes, you have it catted up and everything else. And then, it's like, all right, we are going to be able to have you make like one or two, right? Because you got to be respectful of their time as well. But that's also a great resource for being able to get really nice custom made precision things done, is taking advantage of those local companies and businesses that do that. And you can find them. A lot of times they have engineering in their names. Do a Google search for engineering or something else like that, and you can find them. Even HVAC systems, if you wanted to work with sheet metal, a lot of HVAC companies, so your heating, cooling, stuff like that, have machines for manipulating or brakes or anything else like that for sheet metal. So there's lots of options that are out there if you can put forth the legwork and kind of go and find them, and that can give you that can help fulfill a couple of requirements within FTC, right? Not only could that be leveraged for a competitive advantage with your robot design or get you a more stronger build chassis or whatever else, it also goes back into that making sure your FTC team is engaged with your local community, everything else. And honestly, that's part of the reason why those guidelines exist, of being active in your community, doing that outreach program, is because there are resources out there. You just need to ask sometimes.
Yep. Yeah, and remember, and I'm sure our judge advisors here would agree, so remember the order of advancement for judged awards, it goes inspire, think. The third one's control. Control award's number 3, not control award, connect award, which connect award is specifically connecting with the STEM community. That's what this is, okay? And you win connect award, you're going to state. I mean, that's an almost automatic ticket to state at any qualifier. So that's a good thing to keep in mind here too. So yeah, there's a lot of options here. So don't think that you're limited by just what you have available at your school or in your homeschool group or in your community, because yeah, you have these options here. Also, don't think that you have to start completely from scratch. You don't have to completely, reinvent the wheel when you're building a custom chassis. This design here, this picture that I got here is from a open source thing called BaseBot. which BaseBot was put together by a group of former FTC participants that wanted to make it easier for teams to make their own custom chassis without having to start completely from square one. And so they've put together these files for either, you know, water jetting or for laser cutting that have hole patterns already for GoBuilda, for the GoBuilda style. The other thing about this is that these designs are open source, which means that you actually can go and start off with that hole pattern and you can modify it to whatever your particular needs are. Okay. Or what a lot of teams do when they build their first custom chassis is they'll use the chassis that they already have lying around, be that GoBuilda or Tetrix or whatever, kind of like what Macy mentioned earlier with his team, how he just took, you know, pieces of aluminum and just drilled holes that matched. Don't think that you have to start from scratch. In fact, you probably, you know, you certainly don't have to. There's a lot of options for you if you want to make your own chassis. One thing that I will say about making your own custom chassis, this is recommended to teams who have the time and experience to spend that extra time on designing, creating, and troubleshooting your own chassis. You're going to want to do CAD with this, particularly if you're going to partner with a company or a makerspace. You're not going to be able to go back 5 or 6 or 7 times for most things and be able to just get it right. This is going to take some more time in the design phases and the prototyping phases, making sure that you respect their time. Also, you know, if you're partnering with one of these things, if you go to competition and it breaks, you're out of luck, because you're not going to, most companies aren't going to be open on Saturday for you to go and say, hey, our custom thing broke in the middle of competition. Yeah, you're probably out of luck for that day. Which is another thing that you have to keep in mind, maybe having spares, for example. It does take some extra time. I don't know if I'd recommend this for rookie teams. In fact, I probably wouldn't. I think a rookie team would be better served learning how, unless they have a team that's able to walk them through the process, or some solid mentors. Even then, I think I'd rather have them start on a kit. And then there are a lot of teams that never make a custom chassis. There are a lot of teams that just stick with GoBuilda or Rev or Tetrix, and they make it to Worlds, and it's just fine. This is not something that your team should feel obligated to do after it's been around for a while. But if your team wants that extra challenge, they want the ability to make their chassis more customizable, this is a really good engineering experience. So I'm not going to say that as a general thing, you should make a custom chassis or you shouldn't make a custom chassis. That really depends on where your team is and what your team wants to accomplish. That's really a team by team discussion decision. Nick, do you want to give some of your insights into all this?
A custom chassis can be as simple as modifying a existing kit, or as complex as completely designing your own parts. So I would highly recommend to always build a custom chassis, because if you limit yourself to only what is available within your kits, you're narrowing the scope of what you can accomplish greatly. So my personal recommendation is, don't be afraid to modify things. Don't be afraid to customize, to make your own. That's what makes FTC so great, is if you break something, it's not the end of the world. You're at a price point that for the most time you can find a way to get another sponsorship or something else to be able to get parts. It's also, don't be afraid to use simple things like cardboard for prototyping, or foam core, or inexpensive and cheap product for prototyping. One of the big things that I hope you guys have taken away, or that you're grasping, is that there's lots of options. And then there's more options on top of that. And then there's even more options on top of that. You can definitely get into a position where, oh no, where do I even start? And it's like, if you're in a position where I don't know where to start, get a kit. It's going to help you through most of that. If you're at a point where it's like, all right, I've built a basic robot before, I know kind of how this works, and I want to make it better. Okay, grab some cardboard, or piece of wood, or whatever else, and sketch it. As FTC, as a part of FIRST, you have some great access to free CAD software. Take advantage of it. CADing is gonna, if you take the time to learn the CAD, because it is a learning curve, and I'm not saying it's easy, but if you do it, it will become a great skill to have in your life if you choose to stick with STEM. But outside of that, it gives you a lot of low cost tests that you can do. And now with the thing where 3D printing is a lot more obtainable, you can do CADs, make scale models, a 1-to-1 scale of your robot, do a 1-to-10 scale, see how they work, what spacing would be available. You have a lot of interesting options that you can do. And on top of that, if you have a Tetrix kit or you have a Rev kit now, you can do things with basic tools that are easily gained at Harbor Freight or Amazon, wherever it might need to be able to add to those, or to get
Even Home Depot, if that's all you got access to.
Yeah, Home Depot, Lowe's. You can acquire tools that you need to help make these custom things go, right? And even just getting sheets of acrylic on Amazon. And you can drill acrylic, you can do a lot of fun things with acrylic or ABS, or just getting sheets. It's an easy material to work with, to learn with. There's lots of YouTube videos out there, or with doing the plywood that's thin. You have lots of options for being able to go beyond just the scope of your custom kit. And custom kits, or your pre-made kits, are a great building block.
Mm-hmm.
But if you want to build a robot that will exceed, you got to have your vision, right? So realistically, this all kind of rolls back to, what is the goal of your robot, right? What, going through the engineering practices, what is it that we're trying to accomplish with our robot? Are we wanting it to be fast? Are we wanting it to be slow? Are we wanting it to have great torque? What is it that we need to do to accomplish that? Okay, so now we have an idea. What is it that we need to build to achieve this idea? And you go through that process. You go through that engineering process of going, here's our goal. This is how we can do it. What does that look like? What is everything in part of this? Roll it back. Okay, let's see. Is that still a valid concept? Well, we run into some issues here or there. We're limited by, we only have rev parts, and the rev parts won't allow us to do a West Coast drive, and we really want to do a West Coast drive. Okay, what do you need to do to adapt your rev parts to make a West Coast drive work? Do you need to maybe just attach a piece of flat bar to get spacing appropriately on the side of it? Do you need to do, a small piece of plywood or acrylic to help hold a differential? Are you going to
need to 3D print something?
Yeah. Do I need to 3D print something? Am I going to be in a very messy, game field, like with Rover Ruckus or with Block Party, where there's objects all over the place, or even this year with the rings, and I need to make sure I am not possessing more than I should? What are some mechanisms that I can build with that? Well, hey, maybe I can make an acrylic wall that blocks can't pass under, or a wood wall, or there's lots of options, right? So that's what I would hope you guys are gaining from this, is that in my opinion, you should always have a custom, because any modification makes it custom, in my opinion. And I doubt if everyone only ever stuck to, you know, there's this hole and only these holes and only used textures, become very narrow, very fun or entertaining. But being able to see all of the varied creations with this limited resources because of your custom modifications is so cool. And that's honestly where you're going to learn the most, is when you guys take something that is prefabbed and make it into your own creation.
Yeah, just to be clear, when I say custom chassis on here, I meant like starting from scratch, like building a whole custom system. But yeah, I think I agree with you, Macy, in that, yeah, each robot should be your own. Should have one or more, several components that's unique. And it teaches you how to use the engineering process. Because I think one of the mistakes that a lot of teams that struggle with making their own custom chassis is they want to skip to the end. They want to go, oh, I just want to, you know, oh, cool, I can laser cut this thing. So let me just laser cut this thing. Oh, it doesn't work. Why doesn't it work? Well, did you CAD it? No. Did you prototype it? Did you try it out of cardboard? No. Well, there's your problem. So you really have to be willing to go through the full, you know, one of the things that I'm going to go through with my own team for next year, one of the things that they're probably going to get tired of me saying is trust the process. And when I say that, I mean, trust the engineering process. Make sure that you're thinking it through, that you're designing, that you're prototyping, that you're doing all the things rather than jumping to the last step. And I know the last step's the most fun, you know, actually having it, but Well, one of the great advantages of this workshop is with kind of these simplified games, with the thing, you know, like, you know, driving as fast as you can or things like that. I think this is an excellent opportunity for you to make some custom chassis, to make something that does one of these things in a unique or creative way without, you know, worrying about doing it for entire games. So use this summer as an opportunity to practice some of this. That's the whole point of this thing, after all. So I'd encourage you to think about that and incorporate that into your designs. And I'm excited to see what you guys come up with. All right, well, if there's nothing else, we'll go ahead and move on. Drivetrains. Okay, so what makes a drivetrain different than a chassis? In the way I'm talking about drivetrains, this is essentially how do we get power from the motor to the wheels? When I'm talking about a drivetrain, that's what I mean, is how do you get power from the motors to the wheels? Let's look at the three most common types with FTC. The easiest is direct drive. That's where you just take your wheel, you take your motor, take your wheel, pop it in, you're done, right? Okay. So you just take the output shaft on your motor and you put a wheel on it. That's essentially a direct drive. It's simple, it's compact, it doesn't take up a lot of space, doesn't take a lot of thought, but boy, can this be hard on motors. Direct drive for most situations is not recommended for particularly for drive motors, because it's harder on the motor. You can bend your shaft, you can break your gearbox, and it also limits what kind of gear ratios you can go to. Whereas with the other systems that I'm going to show you, like with gears or chain, you can you have more options in how you can change the gear ratios to match your situation here. So the thing is, I mean, the Tetrix pushbot, I kind of wish they'd redesign that Tetrix pushbot, to be honest. because I think you could do better with the Tetrix system than that basic Tetrix pushbot, because that Tetrix pushbot has that direct drive, and so a lot of rookie teams try that out, and then they do the direct drive, and then they end up bending their motor shafts because that's the way that they did it. So I kind of wish Tetrix would update that. But that's neither here nor there. Anybody want to talk about experiences with direct drive, just plugging in your wheels to your motors? Okay, gears. So gears use teeth to transfer power from your motor to the wheels. Okay, I'm gonna pull up. So this Andy mark, I don't know if you're gonna be able to see this, but this uses a gear drive in here, this particular version of the Tala runner. Point right up here. I don't know if you can see the gears very well, but there they are. So gears use teeth to transfer power from the motor to the gears or to the wheels. Or if you're using this for something else, it'll transfer power to whatever mechanism you're using. So one of the wonderful things about gears, and gears have been around for a long time. In the game manual 0, it talks about how there's a reason why gears have been around since like 4 BC or 400 BC and have been used up till this day, is because they work. They're very effective at changing the gear ratios, the power and torque ratios of things. They're compact, they're efficient. They're a great option to consider when looking at how to transform power from your motors to your wheels. Some cons, however, they're not great for long distances. So if you're planning on putting your motor on one side of the robot and you're going to gear it all the way to the other side of the robot, that's not going to be the best way to do it. Gears are best used in short distances in FTC. Now, one thing you have to consider when doing gears, and this is where a lot of rookie teams make the mistake, is they just slap the gears on there and they're like, oh yeah, they kind of fit together, it'll work. And then they grind it all to heck and they wonder what happened. Anyone had that experience where they've taken a gear and just slapped it on there and it's just a mess after a while? Just me? Just my teams? Yeah, when I was a rookie coach, my first year with FTC, we made that mistake. And the thing is, we did that even on the Tetrix basic bot, which was supposed to be spaced properly for you. I don't know we didn't mesh the gears properly is what happened. And we ended up stripping that gear to heck. And it didn't work after a while. So the thing is, the gears are going to require more thought, more math to get like the proper spacing and things like that. But that comes with a very, very good upside. Laurel, if I can have you jump in here. As a judge advisor, as a judge, if you have a team that comes and talks to you about how they made all this planning to use the gears to do what they wanted to do, how impressed are you going to be as judge?
She's out of the room right now.
Well, I can share a pro tip in the meantime with gears. When you have high impact areas, so like your drive team, where you're expecting a lot of force to hit your gear, instead of just using a single gear, you can pair them up or even triple them up. So you have 2 or 3 gears that are all lined up together. and make sure that they're mounted together. Like you'll notice on the Tektronix gears, they have all of the slots that are off center. And it's like, okay, well, why would you want holes that are off center on a gear? And it's so that you can mount that gear to something, right? Well, you can also mount a gear to another gear, and you can create, 2, 3, 4 thick gears and do the same thing on its matching pair. And what that does is it makes your teeth area a lot wider, which makes it a lot stronger. And so you can do a lot stronger of a connection between the two gears, which means you're not going to break them as easy. So as you're designing and doing things with your gears, that's another thing to keep in mind of keeping your what you're trying to accomplish with your gears in mind as well. Now, the counteract of that is that adds more weight, more mass, and thus you can have loss of efficiency because you have, but you get a lot more strength. So it all depends on what you're trying to do here, right?
Yep. Sorry, I stopped sharing because I wanted to pull up something on Game Manual 0 to show you folks. So, if you're worried about how to use a gear properly, and this has much more information than I think what we're going to have time to get to today, is Game Manual 0 has this entire section about how to mesh gears, how to calculate the different things, how to calculate pitch, how to calculate the distance. This is an excellent resource to go over if you decide to use gears on how to use all these things. Along with, how far apart should your gears be? There's this equation here, okay, which allows you to calculate the distance between the centers of your two gears based off of the number of teeth, the module of each gear, which has the calculations for all that, and divide it by 2. So it's not just guesswork. It's not just slapping gears on there and hoping it works. There's some math behind this, okay? And guess what the Think Award specifically looks for? Do you use math in your engineering designs? So,
Leif,
yes.
Jean said you had a question for me. Sorry, I'd stepped out of the room.
Oh, no problem. So we're talking about gears and, using gears. And we talked about how it's more math, but I said, okay, and the question I had for you to kind of discuss with everybody is, as a judge, how much more impressed are you going to be with a team that says, we used gears and here's the math?
It is literally a decision maker. If you include the math for your gears and math for anything else you happen to do, including angles, even lengths of some of your chassis bars, things like that, it is a game changer for you. Teams that do not use math in their engineering notebook are the first ones dropped on the Think Award. So if you want to make it into those last rounds and get Think, you have got to have math.
Math and engineering. Who would have thought?
Well, engineering is math, only louder.
Yep. Only louder. All right. Other options then, chain drives. So I don't know. Again, it's kind of a pity. I wish I would have taken off a face or something on here before I hopped in here. But this is the kit that comes from Rev, and the default here is they use a chain drive, okay, to transmit all the power between these three things. So chain drive uses chain. Shocking, I know. Chain drive uses chain to transmit power between sprockets, which sprockets are these round pieces with the teeth on them that allow the chain to transmit the power between them. some of the pros with chain drives is they're great for long distances. You can see that with my chassis here, I'm able to chain all three of these wheels together. And it's actually pretty easy to do that. Now, I actually don't have one single chain that does this. I actually have two different chains that do that, but it's really good for longer distances. They're durable. Chain doesn't break very often in FTC. They can be very precise, particularly if you take the time to do the math. I hope we've convinced you to do the math, because the math is worth it. And to change gear ratios. You can change gear ratios by using sprockets with different numbers of teeth. The cons are they can require some complicated math. However, again, if you have game manual 0, it has that equation, so you don't have to remember it off the top of your head. Chain can be bad if again, just like the gears, you just throw it on there and hope it works. Okay. Hope is not a good engineering principle. It's good to know that, yes, we've done the math. We know that it's properly tensioned. Now, of course, there's a lot of hope in, hoping your thing works, but hope is not a suitable replacement for good engineering. So it needs to be tensioned properly. The sprockets can be bigger than the gears in some cases. So, and chain tools, as Nick said, the chain tools. Again, I think they've gotten better. I like the new version of the Rev chain tool. I practiced how to use it on the chassis I built, and it's a feel thing. You really have to feel where that pin starts coming out of that center part without going all the way out, and it really takes some practice to master. Now, you can also use master links, but master links are weaker. Master links are essentially if you accidentally or on purpose pull out the pin entirely, you can splice the chain using one of these master links, but they tend to be weaker than the full chain itself. So something to keep in mind. Or if you don't want to use metal chain, GoBuilda has a plastic chain set that works surprisingly well. That thing is, the plastic GoBuilda chain is rated up to like 100 pounds. And my teams have been able to use that, and it hasn't broken, and it's worn pretty well, and it doesn't require any chain tools. So yay. So there are a lot of options with chain tools. And again, part of the whole reason for this whole thing is to show you how many options there are. There's a lot. Anyone want to talk about their experiences with chain or chain drives?
The plastic one from GoBuilda is really easy to put together, and which makes it a lot easier to get to the correct size, so you can make it longer or shorter really easily. You just have to pull it apart or push them together, and they hold up really well going and can run multiple things. So we really like the plastic one from GoBuilda.
Yep.
I'll share the advisory tale with chain. If you don't have it properly tensioned or properly secured, your chain will come undone and you will be dead in the water. So when you are, and this is not to discourage using chain by any means, it's a great means, especially for transitioning power from a motor that's in the bottom of your robot to an arm on the top, or doing a chain can be a great way for controlling angular momentum of an arm, because it doesn't transfer the torque necessarily directly to the motor. It is a pretty good way for doing that. But if you do not have it properly secured and do not have it properly tensioned where your chain can slip or anything like that. So, when you do use chain, do your due diligence and make sure it is properly tensioned and secured.
Yep.
With that, I would want to mention, don't be afraid to do stress testing before events. So if your robot is, it's Monday or whatever else, you got your robots all ready to go. You guys meet on Wednesday and then Thursday or Friday, and then the competition's on Saturday, right? On Monday or very first thing on your Wednesday meeting would probably be a great time to do some stress testing. Hey, what does it take to break this? Can we break this? How would this break? What would be the necessary steps to fix this? Because sometimes on, first competition day, you're going to have a 5-minute window, maybe a 10-minute window to fix this. Is this a part that can be fixed in that time? What does that take? Make sure you have it with you. So doing some stress testing as well with any of the mechanisms. But I would say, especially with chain, having those mechanisms, how long it takes, what would break it, in the ways of understanding how and why are going to be a massive part for you to have a successful experience with chain.
Okay. Yeah. Thank you. Yeah, just making sure that because any of us, and we've all, all of it, none of us here are rookies. We've all done FTC for at least 1 year. It's not if when things go wrong, is it? It's when. It always is when. And the more prepared you can be for when things go wrong, the better.
Which, if you want a great stress test for, if you're doing like your drivetrain, is chain drive.
Yep.
Set up a long patch that your robot can go up to full speed going forward and slam it in reverse as hard as it can, because that is going to give you the most torque on your chain system, because your robot's going in one direction, your motors now want to go in the other, and that's going to give you a nice solid test. Honestly, that's a great test you do with any of your drive systems. Okay, because that's going to tell you where your weak link is. How do we fix this weak link? How do we make it strong? Because your robot is only as strong as its weakest link.
Mm-hmm.
Right? So, I've done battle bots a couple of times, and one of the things that we always say when you get into larger battle bots is, if you don't feel comfortable throwing your robot off of your second story roof onto cement, your battle bot isn't strong enough yet. So
Yep.
when you kind of put things into perspective of going from FTC into quote unquote real world, right? Is in FTC, you want to learn and apply some of these lessons so you don't have to do it later. Of, okay, how do we do stress testing? What does that look like? How do we identify what our weak link is to make that better? And with chain, it's quite literally identifying the weak link.
Yep. I think I saw something in the chat here pop by. Let's see. Yes. So Caleb says you also need to make sure that you engineer a means of tensioning your chain on the fly. Chains with loose tension. So yeah, chains will loosen over time. Yep. Even on the course of one competition, we found the best way to do this is by using motors with offset shafts. So thank you, Caleb, for adding that, because that is a really good point. Chain will loosen over time. It's also, going along with that, it's usually going into particularly your first few qualifiers. I've begged and I've pleaded my teams. I'm like, please get your robot done at least 2 weeks before, so you have time to practice, so you have time to troubleshoot. And sometimes they believe me, and sometimes they haven't. They're like, nah, we'll just get it done the night before and it'll be fine. No, it often isn't.
So with chain drives, along the same part as what Caleb brings up, having a means of tensioning is huge. So if you notice, one of the probably the biggest example of chain drive I can think off the top of my head right now is literal tanks. Like
Mhm.
think your items in one tank, right? We all know tank tread, everything else. Well, tank tread is chain. That's all it is. It is this chain with one side of it having big flat feet on it so it can grab texture. Okay. So how do you have something that literally weighs several tons ease? And how do you deal with, it all comes down to how that chain is tensioned. So how do they tension their chain on something that big? They use something called an idler wheel. What the idler wheel is it's actually on a suspension system that they can adjust so that as the chain heats up and expands and becomes looser, that idler wheel can be pushed up against it to make it tight against the sprockets again. You can also use idler wheels, not just for tensioning, but also just to make your chain move smoothly, especially like say if it was a single chain going through all three of those motors on the chassis that Lave has. I would probably want to have one or two idlers between the sprockets so that the chain runs smoothly throughout that channel. Bunch of, bouncing up and down. Because as your robot goes and changes, there's going to be torque on that chain, and that chain is going to want to flex. So if you have idlers, it's going to stop the chain from flexing a whole lot, which is going to keep your tension in the same. And then if your chain does expand, you can then, if it's rev with the slots or some other mechanism that you might have to custom design or something like that, be able to shift and change your idler to add or reduce tension on your chain.
Right. And you'll notice, I don't know how well you can see it on here. So right where my finger is right here, that's an idler right there. So there's actually a few of those on here. There's there's two per chain here on this. So just for that reason.
And your idler can be something as simple as just a plastic washer.
Yep.
Spacer.
And that's essentially what these ones are.
Right. Or it could be a sprocket that doesn't have anything. It's just a free floating sprocket, right, on an axle.
Yeah.
You'll notice like the picture here, the axles are off centered, and I'm assuming that's for tensioning just for that photo. But hopefully that kind of gives some ideas if you want to use chain drive.
Yep. So I hope what you come away with this is chain isn't just a slap it on there and hope it works kind of thing. It really, really isn't. You have to take the extra time and effort to make sure that it all works properly. Okay, now for belts. So belts and pulleys. Anybody who ever worked on a car before? Looked under the hood, looked at all the belts and things. Just me? It's one of the things that my dad had me do from a very young age. Oh, yep. Macy just put up his hand. Okay. So it's something that one of the things I'm glad that my dad had me do is I learned how to replace an alternator. And part of replacing an alternator is taking off and putting back on those darn belts and making sure they have the proper tension and all that. So the pros of using a belt drive is they're strong, okay? They're efficient and they're quiet, okay? If you're really, I don't know how much we care about how quiet something is. I'm sure your parents, if you're working with your robot, you're at home, I'm sure your parents appreciate how quiet your robot is. But yeah, Nuclear Minds had an awesome robot, but it was anything but quiet. Belts have a much wider space so you have to take that into account. That's a bit of a con. They're wider than a chain, so you need to have more space for it. But then again, that wider space is also a pro because belts, as long as you tension them and you take care of them properly, are less likely to slip off. Okay, now they can stretch just like chain can, so you'll want some sort of idler system to help adjust the tension as you go. Now, in some ways, you know, when you have a belt, when you buy a belt at the store, you've got that belt for just that one length, and that's all it's good for. Okay, it's not a very easy thing to adjust in a belt without compromising it and compromising its strength. But Game Manual Zero. Now, I've never tried this, so I don't know how great of an idea this is. Maybe someone else does. But apparently there's a lot of things out there where you can actually 3D print your own belts and pulleys for your own like specific things. I don't know how valid of strategy that is just because I've never used it. So I'm just going to throw that out there. But the folks at Game Manual Zero that are experienced have said, yeah, that does work. Nick, do you have any experience on that?
They work well so long as you have a high resolution printer.
Cool.
If it's a very precise part to print. So because essentially, if you've ever like had like an elastic, essentially the way that I've seen them work is it's two pieces that slide within each other under tension. And so you have to make sure that it is well printed. So you have to have a nice high resolution printer. But yeah, it works great. And they can hold quite a bit of force still, even with it being 3D printed.
Cool.
And which allows you to get whatever size you want. Again, that kind of falls back on what's your CADing skills, right? Being able to scale those parts. But yeah, that's yeah, it's definitely probably 3D printing belts is going to be probably a better means other than buying them off the shelf.
Yeah, because you're gonna have to buy a lot of belts.
Yeah,
Sizes.
if you want different sizes, and customization is very limited.
Yep.
You can basically anything you would use a chain for, you can use a belt for, and vice versa. So, you know, sometimes it might be worth prototyping with a chain and then determining, you know, we want a belt because it might be more reliable for this use case. Then, you know, you can look into acquiring a belt once you know what the size of it needs to be, the length, everything else like that. You know, so chain might be a great way to prototype a belt drive because essentially,
yeah, particularly using that go build a plastic train. Yeah, that would be a great prototyping tool for this. Okay, anybody ever used a belts and pulley system for their drivetrain?
We didn't use one for our drivetrain, but we used one for our shooting mechanism.
Okay.
We used a round belt. So we had a higher speed motor that could go really fast. So we used round belt instead of like chains or anything else to drive it. So that if for some reason the ring got jammed or something and the wheel couldn't turn, it would allow it to slip using a round belt. And there's lots of resources where you can just buy lots of round belt along length, and then you just have to heat it and it'll melt it together because that's how the round belt's made there. And it works and it allows slippage if that's what you're looking for. But for like a drivetrain part, I wouldn't think you'd want a round belt.
No, I don't think so. You don't really want your drivetrain to slip in the same way that would be okay for a shooting mechanism. Well, that, yeah, thanks for sharing that. Okay. Well, now we're going to get into some of the last few kind of, and I'm going to try to go a little bit quicker through these things because I want to give you folks, I'm shooting to be done talking by about 2:30. And the reason why I want to give you that last 30 minutes to start talking with your teams and with your alliances about what kind of things you'd like to try from what we've talked about today, or what teams want to try to do what challenge. So we're going to move a little bit more quickly, I think, through the rest of this. Okay, motors. What motors should you use? So some terminology here. Bare motor. So the bare motor is a motor with no gearbox to change the gear ratio. Okay. And most motors in FTC, Rev, Go Build, and Andy Mark have a bare motor velocity of about 6,000 RPM. Some are a little higher, some are a little lower, but they're all right around there. Okay. And then you take your bare motor and you can stick what's called a gearbox on it. And a gearbox is a cylindrical attachment that adjusts the output speed and the torque of the output of the motor, essentially. So I start off with my bare motor and it goes 6,000 RPM. I stick a 20-to-1 gearbox on there and now it goes 20 times slower, is essentially what that means. But it also has 20 times more torque. We'll get to that relationship a bit later on. Now, is it perfectly that way? Well, not quite, because we don't live in a frictionless vacuum, but it's close enough. Okay. There are a couple of types of gearboxes you can get in FTC. The first type is the spur gearbox. Gearboxes uses a series of gears and usually an off-center shaft. That's one of the ways that you can instantly tell if something's a spur gearbox, is if the output, instead of being in the center, is off to one side. That's almost a dead giveaway that it's a spur gearbox. However, there are some sneaky ones. I decided to pull out this motor, okay? This is the Rev Core Hex motor. This is also a spur gearbox on this guy. Okay, so just so you know. And while these guys have their places, they're not great for high load applications. So anything like a chassis or a lift arm, something that's going to be like, particularly if you're doing an arm that's going to lift the robot or something heavy. If you look at this picture, you can see that there's a lot of places on this picture where there's not a lot of teeth interacting with each other, which those are prime places for failure. Game Manual 0 says these are not recommended for drivetrains if you can avoid them, just because they are more prone to break than the planetary gearboxes. Okay. Planetaries. If you have an option, this is what you want to use. So a planetary gearbox, if you were to pull it apart, you would see that there's some sort of center gear, okay, often called the sun gear. So if you think about those really basic models of the solar system when you're in like second, third grade, where you have the sun in the middle and you have the planets rotating around it and things like that. And that's where this gets its name. You have the sun in the middle and you have these planet gears that go in a circle around them. These are superior pretty much in every way, as far as like using them on a drivetrain to a spur gearbox. This is what you should be using. Now, there's a lot of different companies that sell planetary gearbox. Rev does, Tetrix does, Go Builda does, Andy Mark does. So pretty much everybody has some version of a planetary gearbox. And for your chassis, I mean, these are just fine for other things, but for moving your wheels, for your drivetrain, you want to make sure, if at all possible, that you're using a planetary gearbox, just because it will last longer. It's less prone to binding up. This is one of those times where I'm going to say, yeah, this is really what you want to do. Questions?
So I'll say that the main advantage between these two, right, is that one is able to handle resistance to its turning, whereas the other one is not, right? So
Yep.
With a spur gearbox is if you have a lot of resistance, that adds a lot of weight to those teeth, versus planetary gearbox is designed to be able to handle resistance. Now, there are ways that you can counter this with design of your different things that your motor is powering, where, like, say, you could use a worm gear as a transitionary thing where no torque is getting put back on your motor. So there are different designs that you can leverage with what you have to overcome the weaknesses of your parts. Like if you have a spur gearbox, well, if you use something that removes the torque from the gearbox, there's no issue with using that. It just is prone to breaking when there is lots of resistance or counter torque to that gearbox. So if you make some kind of a mechanism that removes that, like a worm gear, there are other designs as well, or even having it go through another gearbox, that gearbox takes the brunt of that, that's designed to handle it, then, you know, those are all things you can do. Like you could easily take and 3D print a planetary gearbox or something else to get the gear ratios that you need and have your spur gearbox interact with that one. Now you are adding 2 gearboxes, which means 2 points of failure that have multiple points of failure within potentially, but you also are engineering a solution that is mitigating a risk of break on your spur gearbox, right? So it all just depends upon the situation, but there's typically a way that you can design around or through a limitation of the parts you are using.
Yeah. Although I will say, particularly since planetary gearboxes are inexpensive and easy to get, even for existing motors, I'd still recommend. I think if you have the money to do it, which some teams don't, and some teams would have to do the adaptation, in my opinion, it's just worth spending the extra money to move to this, in my opinion. I mean, the difference in cost between a spur gearbox and a planetary gearbox is like $4. So it's worth it. Okay. Hashtag not sponsored again, but out of all the motors I've used, if I were to pick one motor, now you could make any motor work. But if I were to invest, if I had money and I was to invest into motors, which I have done before, what motors would I pick for FTC? And the answer is I'd use the Rev Ultraplanetary system. We got these last year as well, 2 years ago now, as part of our robot, and I love these things to death. And the reason why I love this system is because this system is so versatile in what it can do. Because you can go from bare motor to 3-to-1 to 125-to-1, which I don't know. I'm not sure what application you need an FTC that would need something that would have that large of a gear ratio. But if you needed it, it's an option. It makes it so you don't have to buy a whole bunch of motors or a new like let's say you need an arm, okay, that's just for a particular game. Like for example, for Skystone, you need an arm that can lift up the blocks when you're doing that. Well, you can take that Rev Ultraplanetary, put it to the appropriate gear ratio, and have it for there. Well, now Skystone's over, and we're moving to Ultimate Goal. And you want to use that same motor for that shooter, well, now you don't have to buy a whole new motor. All you have to do is just change the cartridges, the gear ratio on there, boom, you're done. And it makes a lot of these motors a lot more reusable than they would be otherwise. Okay. Now, a lot of these motors, just to be fair, a lot of these motors, you can pull off gearboxes on ones that are not ultraplanetary. You can change out gearboxes if you want to. But this system really does make it easy to do. So I would, so if you want some good motors that are good all around, kind of change to whatever you need for it to be, these guys are great in this guy's opinion. So take that for what you will. There are a lot of other good options there. It doesn't mean that if you don't have this, your robot stinks and you're not going to win anything. That's not what I'm saying. I'm just saying if you have the money, if you have the resources, and you're wondering what motors to buy, this is the one I would tell you to buy. just because of how versatile it is and how easy it is to change the gear ratios to whatever application you need it to be. Cool. Call me Rev, because I could use some sponsorship money. Okay. Choosing the right gear ratio for your motor, particularly for your drivetrain. So gear ratio, if you're confused about what that means, it's essentially how many times the motor spins in a ratio to how many times the output shaft spins, whether that output be in gears or on chain or what other not. This is just essentially saying, okay, how many times does the motor spin for every one time the thing I want at the end to spin? Okay. So for example, if I have a 20-to-1 gearbox, that means that my motor will spin 20 times for every one time that the output shaft will spin. Okay. So therefore, the higher the gear ratio, the slower the output shaft will spin. Okay. And this is typically how we talk about it. When we talk about it now, there's up gearing and down gearing, and we don't have a ton of time to go over all that. But when we talk about a motor, this is what we typically mean, is this. Okay, so some basic math. So if you want to know how fast your output shaft is spinning, if you have a 6,000 RPM motor and you put a 20-to-1 shaft on there, all you have to do to find out how fast your output shaft is doing is just divide by 20. That's it. To get the theoretical top speed there. So if you've got 6,000 RPM, you just divide it by 20. There are some factors that do affect how much it will actually spin. There's friction. We don't live in a frictionless vacuum, but it works pretty well for this application. And again, this is a nice, easy way, some easy math to put in your engineering notebook and say, hey, here's our output shaft velocity here, and here's why we chose this velocity. Hint, hint, if you want to win the Think Award. Okay, another thing when you think about what gear ratio to use is torque. Torque in a physics sense is just, it's a force in a circle. It's a twisting force. Not a lot of you, some of you might have taken physics in high school yet. A lot of you probably haven't. I know a lot of my students haven't yet. You'll learn all about how to calculate torque and all that. We're not going to get too much into that, but suffice it to say, the more torque you have on your wheels, the faster your robot will accelerate, meaning being able to go from 0 to top speed. Okay, higher torque means higher top, or quicker it's going to be able to get to top speed. Better it's going to be able to climb up obstacles or be able to push objects. Okay, so torque is all about that power. Okay, being able to push things. And as it turns out, the torque of a motor increases by the same factor as the gear ratio. So when you're putting on a 20-to-1 gearbox, yes, you're lowering the speed by a factor of 20, but you are increasing the torque theoretically by the same amount. Now, again, there's things like friction and all that, so it's doesn't end up perfectly being that way, but again, close enough for what we're talking about here. So when you're looking at a gear ratio, you're looking for the right speed. You want a high speed when you want to go fast on your robot, but you also don't want your robot to take forever to accelerate to top speed or be able to be pushed around by other robots. So there's kind of this trade-off that you've got to carefully consider when thinking about that year's game is, okay, is speed more important in this year's game? Is having a high top speed most important? Or is torque more important? For the events for this year's, and this is one of the reasons why we designed the events this way. We have one event, the 10 decimeter dash, 100 decimeter dash, 10 meter dash, where it's all about speed. It's all about, okay, how fast can you get to A to B? Can you ignore torque though? Not quite, because again, torque will help determine how quickly your robot will get to top speed. So, but there's a different equation there as opposed to event 3, which is going up the incline. Okay, what's the right torque? You know, you're going to want the top speed isn't going to be nearly as important in that scenario as how much torque, making sure that you have enough torque to climb up the incline. So very, very big things to consider and to play around with in practice as you build your robots this summer. Okay, so what are the better torques for or gear ratios for most robots? This is based off of the folks from Game Manual Zero, so the folks that have had experience in FTC. And they give different recommendations based off of the diameters of your wheels. Because the formula for torque, one of the key things for torque is how big your diameter, how big your circle is. In this case, how big your wheel is. So depending on how big your wheels are, you're going to want to use different motors. So here are two of the most common wheel diameters in FTC. So you've got 4-inch wheels. They recommend using somewhere between 16:1 and 20:1. A lot of teams say that somewhere around 19.2:1 is the magic number. Again, I'm very hesitant to believe one-size-fits-all solutions because not all robots are the same, not all games are the same, not all situations are the same. So keep that in mind. But somewhere between 16:1 and 20:1, according to people that have done FTC for many years, this gives them the right balance between speed and torque to get done what needs to be get done in that particular game. Now for 3-inch wheels, again, because you're using smaller wheels, you're going to want to gear it a little lower. So somewhere between 12:1 and 15:1. Motors like this, the Rev, this guy here, this one's geared to 40:1. This is typically, for most applications in a regular FTC to game, 40:1 is probably a little too slow to be competitive. You're sacrificing too much of your top velocity for torque for a lot of things. However, for this camp, particularly with the incline, that advice might not be the same here. We have a very specific set of circumstances that you might consider or try out something like a 40:1 and see what happens. Okay. So these recommendations are just based off of your typical average FTC game, but there might be changes. Nick, do you have any any basic bits of advice with this?
Your gear ratio, right, is that it's a ratio. So make sure you understand the RPM of your motor going in, the characteristics of it. I know some of the motors don't have very good data sheets that are available to actually tell you about the motor, but that information is mostly out there. You know, I just have to do some research. Again, it all depends on what you're trying to accomplish. You know, for one, when we did so we had a motor that we purposely wanted to go very fast, because the thing you have to keep in mind is you have a gearbox on your motor, which has a ratio, and then if you do, you know, gears, your gears could have a ratio. If you do chain sprocket, that could have a ratio. And in this particular case, we had a gearbox going into a chain sprocket that went up to a worm gear that went to a gear to facilitate a linear lift. And so when all is said and done, when we're calculating, okay, what is our gear ratio for our motor to our linear lift, it's not just 20-to-1 gear ratio of our gearbox. It's
No.
the gearbox plus our chain sprocket plus our worm gear plus anything else. And it's like, okay, so in this particular case, we have options now. My chain sprocket can be leveraged to make different gear ratios if we need it, but we did a 1-to-1 gear ratio. Then you go to the worm gear, which the worm gear was a 1-to-4 ratio by the very nature of how the worm gear is. So we automatically, if our motor was a 20-to-1, we now have a 24-to-1 ratio because of our worm gear being involved in the chain. And then we had a gear that we had torque up so that we were actually closer to a 10-to-1 because we wanted the speed. Because our worm gear already got of our robot going into our motor, we wanted it to go faster. So we actually put in a gear system to make our linear lift faster, even though we didn't change anything about our gearbox. So as you guys are designing your mechanisms, keep in mind that your gear ratio can be changed many different ways. And it's like for us, we wanted to be closer to 10-to-1 or even 5-to-1. So we had a very fast thing. We leveraged a worm gear to get around the weight of the robot, putting weight back onto our system. And so we were able to do a gear ratio between the worm gear and our motor that allowed us to go faster as opposed to slower with higher torque. So we actually did a reverse gear ratio on one of our gearing systems so that it was faster going into the worm gear.
Okay. So yeah, keep all that in mind. There's lots of ways you can change a gear ratio between your motor and your wheels or whatever mechanism you're using for this. We're starting to run a little low on time, so I'm gonna move right along here. Just mention that. Last little bit is just some miscellaneous tips and tricks as you work on your chassis. One, plan ahead. Okay. Plan where your rev hubs and cables go ahead of time. Okay. Again, the more you can CAD things out, the more you can think ahead, the less you're going to hate yourself when you actually get to competition time. Because when you're like, oh yeah, I'll just slap this on here and it'll be fine, and there's some headaches that can be had, particularly if you have cables that are just a mess and all over the place and unnecessarily complicated. Just plan ahead. The last thing you want to have happen, there's a lot of ways you can have a dead robot. One of the most unfortunate ones to see is to have a wire pop out because they ran an arm next to it. It got caught and it pulled it out, and then the robot just sits there. And you're like, well, that's terrible. I wish that didn't happen, but that's what happens when you don't plan out where your wires are going to go. And a lot of teams forget about this. Make sure you know or have a plan for where your wires are going to go, along with all of your other components.
Pretty much all of the kits ship U-channel, right? And U-channel gives you an excellent space to route wires. So one of the things that I would highly recommend is as you design your layouts, run, if you're doing a cardboard mock-up or something like that, run some wire, see where you can hide it. Because the better that you protect your wires, the better it's going to be when it comes to inspection and for competition. If your wires are also neat, nice, and organized, when it comes to troubleshooting any kind of hardware issues, that's going to be a lot easier and faster. Also, it's going to get you brownie points with any of the inspected robots. When everything's laid out nice and neat, it's going to be like, oh, this is really nice. To the point that there have been recommendations from inspectors to judging before for different things. Whether or not that makes an impact, I don't know. But any positive word from any event staff goes a long way in making decisions or tiebreakers, right? So I can definitely say that with judging. So if you spend the extra time to go through and design your robot with a place in mind for where your cables are going to go. It's going to be more work up front, but it is going to be a lifesaver later on.
It's worth it.
Especially almost doubly true for batteries. Where are
Oh,
you going
yes.
to put your batteries and everything else? And we actually had a robot this last season that had an issue with power delivery because of the way that things were wired. So, you know, we're not necessarily going to talk about that today, but as you guys think through things, think about how stuff is wired and where it is, because you are limited in scope for your power from your battery, right?
Yep. Okay. Yep. Some
Nick?
other things. Oh, go ahead.
Sorry, to answer what Nick said about he's not sure how it affects judging. It affects it quite a bit. Any comments we get from any of the other volunteers is definitely taken into account.
Yeah.
Okay.
So I guess the short answer: if you want to win judging award, brownie points go a long way.
Yes.
Very, very true.
And sometimes actual brownies.
Although my stomach doesn't
Okay.
thank you. Oh.
Okay. All right. Tighten, but don't over tighten. This graphic comes from Rev's basics, or the Rev FTC starter guide. You want to make sure that all your bolts are tight, because one of the worst things, you don't want to see robot parts being strewn across the field. Okay. It's not a good thing for anybody. But you want to make sure that you're not over tightening. So you can see in this little graphic that it's possible to actually bend the channel, the extruded aluminum, if you just really, you're like, I gotta get this as tight as possible. No, you don't. You do not need to get this as tight as possible. You need it tight enough. Okay. You need to make sure that's, in fact, the phrase that Rev uses over and over again is snug, not tight. You don't need to, if you're like twisting with all your might to get your bolts on, you're twisting them too hard. So be careful with that as you put together your chassis.
And if you're not sure if it's tight enough, try moving it by hand. If you can't move it by hand, it's probably tight enough.
Yep. Unless
And
it's one of
again-
those Tetrix bolts, and in that case, no tight is tight enough.
Right. And again, that kind of loops back to do stress testing.
Mhm.
You know, okay, we got a point fixed. This is an important cross member for our thing. You try and move it. Okay, it's not moving. All right, now go to an extreme. You know, really try and torque it and move it. Not tightening your bolt, but the actual member that it's supposed to be secured, right? And if it slips, okay, maybe it needs to be a little bit tighter. If it doesn't slip, it's tight enough.
Yep. Use lock nuts. Don't just use regular nuts. They will come off. You'll be finding them all over. You'll find paths of them wherever your robot's been. Use locking nuts. They're not that expensive. So if you have a kit like Tetrix nuts, they're not good enough. Use them for jewelry, things like that. If you have a Tetrix kit, go ahead, just go buy some lock nuts. Nylocks. This is a picture of a nylock bolt or nut, nylock nut. They're inexpensive. They're easy to find. You can find them on Amazon. You can find them online. You can buy them from, there's a lot of places.
So,
and it's a big upgrade for just a few bucks.
one mistake I do see a lot of people make with the nylock nuts, though, they are not reusable. What I mean by that is that the locking, so the way that the nylock actually locks is it has a ring of nylon at the tip, right? That's that plastic piece. When you tighten your screw in, that nylon gets displaced and it wedges into the bolt so that any vibrations or anything like that, it won't slip back on the threads. That's what the nylock does. So after you have tightened a bolt and engaged that nylock will not do a proper securing ever again. So that doesn't mean you can't use nylock nuts multiple times. It just means that when you guys are finalized your system and you're getting ready for competition, if it's a nylock nut that's ever been removed, I would recommend putting a fresh one on so that the locking mechanism actually works. Even with nylock nuts, we still see a lot of them show up on the competition game field. And you can actually look at it and you can see there are different teeth marks in the nut because it's been reused. So just keep in mind that if you really want your nylock nuts to not come off, they are single use only.
That's good to know. Other options is you can use things like Loctite. Now you need to be careful when using Loctite because there are two levels of Loctite. Now, one level is really tight, but it's possible to get off with normal tools. And then the other level is, yeah, it's on there. You don't want, Loctite is something, if you're going to use it, you're going to use it once you know everything is the way that you want it, that you're not going to make any changes, that it is where you want it, and then you apply the Loctite. You don't want to apply it earlier in the process.
So who in the audience knows what kind of fastener Loctite is? Right, so you have mechanical fasteners, adhesives, glues, so what is Loctite? Does anybody actually know what Loctite is?
I think we probably ought to just go into what it is because, again, we're running short on time.
Loctite is an adhesive.
Yep.
So what you're literally doing is you are putting a semi-permanent glue on the threads. So it's essentially trying to, again, replicate the same thing as the nylock nut, where your fastener, your mechanical connection of your bolt and your nut cannot, due to vibration, forces, or otherwise, slip back or rotate, basically so that the nut can't rotate backwards off of your threads. So Loctite is a glue. It's an adhesive designed for that. So it has a breaking point, but if you put too much on it, you're never going to get that thing off. So the other thing I would say is if you're using Loctite, a little goes a long ways because, again, you're literally putting glue on a mechanical fastener.
Yep.
And as for the different kinds of Loctite, generally the blue one is going to be your removable one. If you use the red one, that's the permanent.
Yeah, forget about it.
I've had to remove ones with red. It is extremely tough.
You're more likely to break the bolt.
Yep.
Or your tool.
Yeah. Or both. Okay, other things to think about. I'm just going to kind of cruise through these a little bit. Center of gravity. Center of gravity is essentially the point of average mass for your entire robot. So if you want to think about an object's center of mass, like let's say this remote here, okay? The center of mass is the point where I can put my finger on it and it balances, okay? Unless I knock it off with my own clumsy hand. Okay, so it's the average point of your robot. Generally speaking, the lower your center of gravity can be, the more stable your robot is. Also, your robot will turn around its center of gravity. So that's something to keep in mind, particularly for some of the drivetrains that we've talked about today, like Mecanum and the X-Drive. Knowing where your center of gravity is going to help you make better decisions, particularly when it comes to things like autonomous, on where things are going. So yeah. And generally speaking, the thing is, in order for something to tip over, you need to put your center of gravity, you essentially put your center of gravity away from its base, or so it's not standing over its base. One way you can,
your center of gravity has to be above your center of mass.
Yeah. So essentially, you can try this out. Like if you stand up and you kind of start leaning forward, eventually you'll stumble because your center of mass will.
And I'll throw this out there real quick. If you guys are not understanding center of gravity versus center of mass, let me know in the Discord. And
Yeah.
we can set up a thing where I'll use Kerbal Space Program and it'll actually show you the calculations for center of gravity versus center of mass and help actually give that in a visual representation. So if that's
Right.
something you guys are interested in, hit me up in the Discord. We'll set up a time to do a stream in Discord doing so.
That'll be great because we're kind of out of time. And that's it. Okay. So, all right. Well, ended a little later than I thought we would, but I think we got some great stuff here today. I hope that you folks got some things that you can take away into your alliances moving forward. Do any of you folks have any like last questions you want to ask about anything that we've talked about today with chassis and all these different options? Okay, well, for the rest of the, so this camp or this workshop's designed to go till 3 o'clock, but now here's kind of the it's up to you kind of part. Now that we've gone over these options, we'd like to invite you to talk it over with your teams and with your alliances and start getting some design ideas for how you want to, or what teams are going to take what challenge. Okay. So you might have one team take the speed challenge and another one take the climbing challenge, and start discussing amongst yourselves, you know, how you can best use the time and resources that each team has at its disposal. I've been talking for too long. Okay, well, if you ever do run into any questions, you can, so all of the leaders here, all of us counselors are on the Discord. Feel free to reach out to us. We're happy to help you. And yeah, I think we're pretty well done with this. Thank you for your participation here. Thank you for those that added their own experiences. Okay, what if we can't get onto Discord?
Can you explain what you mean by that?
So we attempted to make an account, but every time we get in, it pulls up something's going wrong. So we try and put in a phone number and it says it's a VoIP or landline, but it's not. So it won't do anything.
That is weird. I have not seen that before. Yeah, I have not seen that before.
Might be you might want to try from an incognito tab or clear your browser cache and try again. That sounds like there might be something funky with the browser with registering with Discord.
Yep.
So I would try a different browser or incognito mode or in private mode and try registering again with Discord. Yeah, is there anyone that has anybody else having issues with getting into Discord? Doesn't know how to use Discord, anything like that, we can help cover. Our hope is that we can leverage the Discord as a great means to collaborate together and have resources more readily available to you all during this time.
And not only during this camp, but throughout the season. We plan to use this to announce events, to announce everything. I have seen a few people join while we were on here. Enoch, yes, just your first name and your team number.
Yeah, so it'd be Enoch 16028 in your case.
Once you're on the server, your Discord username can be whatever you want. Just make sure that on the server it's nicknamed that way.
Yep.
And then if you haven't already, make sure you guys fill out the Discord or the
form so that we can
form.
So we can give you access to the robotics camp group. Also, before we can do anything, you need to accept the rules. So if you're on the Discord and you haven't accepted the rules, make sure you do that, because otherwise we're stuck.
Yeah.
You don't. And also parents, coaches, we need you on here as well. Otherwise, we go out of compliance with youth protection and we get shut down.
Yep.
So we need parents and coaches on there as well.
All right. Anybody else have any other general questions or anything about the live competition? Anything about any of the other events? Anything you're just dying to ask? Okay. Was this helpful? Was this helpful to talk through all these different things?
Vikram said yes.
Yes,
Not sure
good.
what in response to.
So I hope it has been. I hope that you folks have benefited from this. All right. Well, I think we're just about ready to shut down here and leave you folks to discuss amongst yourselves and your coaches on the Discord about your strategies for starting to get building your robots. Next week, we've got our sensors block. So look forward to that. We'll be talking about color sensors, distance sensors. We're going to be talking about magnetic limit switches, all these kind of things that you can use to upgrade what your robot can do. Along with using, both the cell phone cameras and web cameras on your robot. So that's the focus for next week. So if programming is interesting to you, and even if it's not, come anyway. Because knowing what things are out there, it really helps with the overall design and build of the robot. So we hope to see all you next week. Same bat time, same bat channel, right?
Real quick, one more thing. For those who are having trouble joining the Discord, because I do see a few accounts have joined a couple times. When you fill out that form, make sure you include the 4-digit number after the hashtag symbol, because that will tell us which one is actually you and which one we need to delete.
All right. Well, I think we'll close it off here.